Imagine yourself floating in the darkness of space, watching as countless specks of stardust begin their eternal dance around a young and brilliant sun. You drift weightless through the void, suspended in the vast expanse where time moves differently than it does on Earth. Around you stretches a nebula of incredible beauty, a swirling cloud of gas and dust that catches the light of distant stars. This is the solar nebula, the birthplace of your world. Though no world exists yet, everything is potential, everything is becoming. The sun pulses with newborn energy, having ignited only 1,000,000 years before your observation begins. Its gravity reaches outward like an invisible hand, drawing the surrounding matter closer. You watch as gravity works its patient magic, pulling microscopic particles together. Dust grains collide and stick, forming pebbles. Pebbles merge into larger rocks. The process is slow yet relentless, indifferent to time itself. Around the young star, the temperature varies with distance. Where you float now is the perfect zone, where metals and silicate rocks remain solid, while gases drift further outward. Here, in this temperate band of the solar nebula, the building blocks of terrestrial planets accumulate. You witness the coalescence of matter into planetesimals, rocky bodies ranging from a few kilometers to hundreds of kilometers across. They are the seeds from which worlds will grow. These planetesimals do not float peacefully. They are on collision courses, engineered by gravity itself. As you observe over what would take thousands of human years, the cosmic dance becomes increasingly violent. Two planetesimals intersect and merge in a catastrophic embrace. The impact creates a brief flash of energy, melting surfaces and releasing heat into the surrounding void. The merged body grows larger, its gravity strengthening, its appetite for more material intensifying. Hour after hour in your timeless observation, collision after collision reshapes the architecture of this young system. Planetesimals merge and consolidate. The number of independent bodies decreases, while their individual sizes increase dramatically. Within a few million years, a proto-Earth emerges, a body perhaps half the current size of your planet, still growing, still hungry, still surrounded by countless impactors waiting to collide. The violence intensifies further. What was once a gentle coalescence becomes a chaotic bombardment. Planetesimals miles across slam into the growing proto-Earth with shocking force. Each impact releases tremendous energy. The proto-Earth grows hot, its surface molten, glowing faintly in the darkness. The collisions come faster now, driven by the ever-strengthening gravity of this growing world. Around it swirls a disk of remaining material, dust, gas, and smaller rocky bodies, all destined for collision and merger. You feel a sense of awe as you observe the sheer scale of cosmic engineering happening before you. This is creation at its most primal, violent yet purposeful. There is no intention here, yet intention seems to guide the process. Gravity is the architect, collision is the tool, and time is the canvas upon which this masterpiece is slowly painted. A particularly massive planetesimal, nearly the size of Mars, strikes a glancing blow against the proto-Earth approximately 50 million years into your observation. The impact is so enormous that it sends a vast plume of vaporized rock into space. This debris will eventually coalesce into a satellite, a moon that will forever circle this world. But you cannot yet see that future. The bombardment continues relentlessly. The proto-Earth swells with each impact, pulling in more and more of the remaining material in its orbital path. Smaller bodies disappear into its molten surface. The planet's rotation accelerates from the angular momentum of these collisions. Gradually, ever so gradually, the frequency of impacts decreases. The population of impactors dwindles. The solar system grows more organized, more peaceful. You drift in the cosmic silence, watching as the dust settles, literally and metaphorically. The proto-Earth has become more definitively Earth-like, though you would barely recognize it. It is a world of molten rock, wrapped in a thin crust that perpetually forms and breaks apart from the residual heat within. There are no oceans yet. There is no atmosphere. There is no life, no sound, no color save for the dull red glow of cooling lava. And so, in the silence of the cosmos, a new world is born. The newly formed Earth is a world unrecognizable to our modern eyes, a burning sphere suspended in the void, its surface writhing with the violence of creation itself. Imagine drifting through the cosmic darkness, approaching this infant planet some 4.5 billion years ago, and what you would witness is nothing short of apocalyptic. The entire world glows with an angry, molten luminescence, casting an eerie orange and red light into the surrounding space. There is no familiar landscape here, no continents or oceans as you know them. There is only fire, endless fire, churning and roiling across every surface. The Hadean Elon, named after the ancient Greek underworld, earned its designation honestly. The temperature at the surface hovers around 2,000 degrees Fahrenheit, hot enough that rock itself behaves like flowing water. Imagine watching from a safe distance as vast oceans of lava surge and undulate across the planetary surface, creating waves of molten stone hundreds of feet high. The crust, such as it is, remains incredibly thin and fragile, constantly breaking apart and reforming as the intense internal heat seeks escape into the cold void of space. But Earth is not alone in this cosmic neighborhood. The young solar system is a chaotic place, still crowded with planetary embryos and countless smaller bodies of rock and ice. A constant barrage of meteorites and asteroids rain down upon the surface, each impact releasing tremendous energy. Imagine the thunderous roar as a massive space rock, miles across, plunges through the thin atmosphere and strikes the molten world below. The collision creates a flash of searing heat, sending superheated material spraying upward in a tremendous arc. These impacts are so frequent and so violent that the surface never settles into stability. The very ground beneath would shift and crack with each successive strike, new craters forming and old ones vanishing into the churning mantle below. The atmosphere surrounding this hellish world bears no resemblance to the air we breathe today. There is no oxygen, no nitrogen in familiar proportions. Instead, the sky roils with toxic gases. Hydrogen, methane, ammonia, water vapor, and carbon dioxide billow upward from countless volcanic vents. The young Earth is extraordinarily volcanic. From every crack in the thin crust, molten rock and noxious fumes pour forth. Imagine standing at an impossible vantage point and seeing 1,000 volcanoes erupting simultaneously across the entire planetary surface, each one adding its own contribution to an utterly alien atmosphere. The sky would appear murky and turbulent, a sickly haze through which no sunlight penetrates clearly. And yet, despite this seemingly hostile environment, something remarkable is beginning to happen. Water, brought to the young Earth by countless icy comets and asteroids, is beginning to accumulate. As meteorite impacts slow slightly during the tail end of the heavy bombardment, and as volcanic outgassing continues to release water vapor from the planet's interior, something miraculous begins. The water condenses and collects. The first rains begin to fall, great sheets of precipitation cascading down from the turbulent sky. These are not the gentle rains you might imagine. These are torrential downpours of hot, acidic water, and they continue relentlessly. Over millions of years, these waters accumulate in the lowest places, and the first oceans begin to form. What is forming in these early oceans is something profound. Within the boiling, mineral-rich waters, and fueled by the incredible energy available from volcanic heat and chemical reactions, the building blocks of life are assembling. Complex organic molecules are forming through purely chemical processes. Amino acids and other compounds essential to biology are creating chains and structures of increasing complexity. The chemistry is extraordinary and intricate, far more sophisticated than the simple atoms from which it springs. This is a world of extremes, a place of terrible beauty and incomprehensible violence. The Hadean Aeon represents creation in its rawest form, the moment when physics and chemistry dance together in an ancient waltz. The planet is being shaped by impact and heat, by gravity and nuclear decay deep within the core. Every meteor strike, every volcanic eruption, every chemical reaction taking place in those first oceans is a step toward something greater. In this inferno of becoming, the seeds of our world's future are being sown. Picture the unimaginable. A planetary body the size of Mars, moving through the void on a collision course with our newborn world. Our young Earth, barely formed, orbits in a solar system still chaotic and violent. The planet is a roiling sphere of molten rock, its surface a nightmare landscape of erupting volcanoes and collapsing impact craters. This is a world utterly alien to anything we know today, a hellscape of incomprehensible heat and destructive energy. Yet into this inferno comes something even more catastrophic. The object, which scientists would one day call Theia, races silently through the darkness of space. It is a protoplanet, massive and ancient, perhaps as old as Earth itself. It has traveled through the primordial solar system for millions of years, following a gravitational path that seems almost inevitable in retrospect. The young sun's gravity, combined with the orbital mechanics of countless other bodies, has guided Theia on an inexorable trajectory. And now, after an unimaginable journey through the cosmic dark, it approaches the moment of collision. The impact, when it comes, is almost beyond comprehension. Theia strikes Earth at an oblique angle, hitting the planet not head-on, but with a glancing blow that is somehow even more catastrophic than a direct collision. The relative velocity is staggering, kilometers per second, and the energy released is so enormous that it makes all the volcanic fury of Earth's formation seem like gentle warmth. In an instant, the temperature at the point of contact reaches millions of degrees. Rock becomes plasma, solid matter vaporizes. The very substance of two worlds collides and begins to transform. The explosion of energy sends a shockwave through Earth's mantle and crust. The planet reels from the impact, its entire body shaking. Mountains that existed for mere millennia are obliterated. The crust fractures and ruptures. Vast quantities of the upper mantle are excavated and thrown upward into the thin atmosphere that barely exists around our young world. The molten rock, superheated and violent, rises higher and higher into space, escaping Earth's immediate gravitational pull. Theia itself, struck with such tremendous force, does not survive intact. The planetary body breaks apart, its material scattered in all directions. Some of it is hurled far into space, escaping both Earth and the sun's gravity altogether, becoming wandering fragments in the darkness. But much of it remains, trapped within the gravitational field of our battered planet. The debris from both worlds, Earth's and Theia's, begins to orbit around a common center of gravity. What was once two distinct bodies is now a swirling ring of molten material, a chaotic disk of planetary fragments orbiting the still molten Earth. Over the span of days and weeks and months, something miraculous begins to happen within this ring of debris. The pieces, still hot enough to flow like liquid, gradually begin to coalesce. Gravitational attraction pulls the fragments together. Slowly, inexorably, they spiral inward and merge, growing larger and larger as they accumulate more and more material. Collisions between these growing bodies generate more heat, but gravity relentlessly draws everything together. Within perhaps a century or two, a new body has formed from this cosmic debris. It is spherical and substantial, though smaller than Earth itself. It emerges from the chaos of the collision like a phoenix from fire, a wholly new creation born from destruction. The material that forms this new body comes from both worlds, Earth and Theia have merged their essences, and from their union comes something entirely unprecedented in the history of our solar system. This new companion settles into an orbit around the damaged, but still intact Earth. It hangs in the sky, a constant presence, massive enough to profoundly influence its host planet's behavior through gravitational interaction. The tides that will one day sculpt continents and nurture life cannot yet exist, for Earth is still too hot for oceans. But the gravitational dance has begun, a relationship that will shape Earth's entire future. From this cosmic tragedy would emerge one of Earth's greatest gifts, a celestial companion to light the night sky. Slowly, imperceptibly at first, the burning surface of our world begins to calm, as if the universe itself is encouraging rest. Imagine yourself drifting through the void, watching from an impossible distance as our young Earth transitions from a seething inferno into something almost recognizable. The violent collisions have ceased their relentless rhythm. The giant impact that created the moon has faded into memory. And now, in the profound silence of space, something quieter and more profound begins to unfold. 4.5 billion years ago, our planet starts the patient work of cooling. It is a process that will take millions of years, yet from a cosmic perspective, it happens almost instantaneously. The surface temperature, which once exceeded the melting point of rock itself, gradually begins to decrease. Picture this slow transformation like a blacksmith's forge, gradually dimming as the flames subside. The radiant heat still escapes into the vacuum of space, carrying away the fury of those early cataclysms. As the outer layers cool, something extraordinary begins to happen. The very first solid crust starts to form, a thin, fragile shell hardening upon the surface of molten rock. This is not the steady, stable crust you would recognize today. Rather, it is delicate and fractured, constantly broken apart by the tremendous heat still radiating from below. Imagine a skin forming on cooling pudding, only to be disrupted again and again by internal convection. These early crustal fragments are scattered across the planetary surface, like the pieces of a puzzle that will take eons to properly assemble. This emerging crust represents an enormous transition in Earth's history. For the first time, there is something solid, something that could eventually support the formation of continents and ocean basins. It is the foundation upon which everything else will be built. Yet it remains incredibly hostile to anything we might recognize as life. The surface is still bathed in harsh, ultraviolet radiation from the sun, and it is bombarded constantly by meteorites and asteroids. The atmosphere, if you could even call the thin veil of gases surrounding Earth and atmosphere, bears no resemblance to the life-sustaining air of future ages. Feel the weight of time settling upon this moment. Hundreds of millions of years are passing as the cooling continues. Small impacts strike the crust, and the heat from these collisions briefly melts the fragile surface anew. Larger asteroids create vast scars and basins, yet the overall trend is toward greater stability, toward the slow accumulation of solid material. The crust thickens incrementally, grain by grain, degree by degree of temperature loss. Beneath this forming shell, however, the planet's interior remains in constant turmoil. The core, composed primarily of iron and nickel, continues to radiate intense heat outward. This heat drives currents within the mantle, the thick layer of rock between the core and the crust. These currents, still raging and turbulent, will eventually power plate tectonics, though that process lies millions of years in the future. For now, they simply keep the planet's insides in motion, preventing the world from ever reaching true stillness. Water, that miraculous substance essential to all future life, cannot yet exist in liquid form on the surface. The temperatures remain far too high. Yet evidence suggests that water vapor was present in the atmosphere, delivered partially by the planet's own interior and partially by countless asteroids that carried this precious molecule across space. This water vapor will eventually become crucial, though it remains invisible in the superheated air of the Hadean Eon. This chapter in Earth's story is one of profound transformation, though it occurs in near silence and utter darkness. There are no witnesses to this process, no creatures to observe the gradual solidification. The moon hangs in the sky, its surface fresh with the scars of formation, orbiting at a distance much closer than it would eventually travel. It serves as a silent guardian and gravitational anchor for the world below. The cooling continues, patient and inexorable. Each passing million years brings incremental change. Layer by layer, molecule by molecule, the burning world of yesterday becomes merely a hot world of today. This is the rhythm of deep time, the heartbeat of planetary formation. Beneath this fragile new crust, the molten heart of Earth continues its restless work. From countless volcanic vents across the burning landscape, the elements that would become our atmosphere pour forth into the void. Imagine standing at the edge of this primordial world, where the ground itself breathes fire, and the very substance of creation is being released from deep within the planet's churning interior. The Earth at this moment is unrecognizable compared to what you know today. There is no sky of blue, no clouds drifting peacefully overhead. Instead, there is a thick, roiling chaos of gases, erupting continuously from fissures that crack across the still cooling surface. These are not gentle eruptions, but relentless outpourings of the planet's inner chemistry. A grand exhalation that has been building pressure for millions of years beneath the hardening crust. Deep within the Earth, in that molten realm where rock flows like water and pressure beyond comprehension rules the environment, countless volatile compounds have been trapped since the planet's formation. Water molecules, carbon dioxide, nitrogen, ammonia, methane, and sulfur compounds exist in the superheated depths, locked away in the minerals and rocks that compose the bulk of our world. But now, as the core continues its relentless cooling, and as the weight of the accumulating crust increases, these substances find pathways to escape. Picture the ground opening in long, spreading cracks. From these wounds in the Earth's skin, enormous volumes of steam and gases rush outward and upward. The volcanic vents are not isolated phenomena, but part of a global system of release. Everywhere you look across this barren, rocky landscape, there is activity. Fumes rise in shimmering columns. The air itself becomes thick with the products of planetary chemistry. Water vapor dominates this first atmosphere, released from the deep rocks where it has been bound for eons. This moisture rises into what will eventually become the sky, carrying with it the signature of Earth's aqueous interior. Carbon dioxide pours forth as well, a heavy gas that begins to accumulate in the space above the surface. This greenhouse gas will play a crucial role in the planet's climate story, warming the world in these early days. Nitrogen, that essential element of life's future proteins, emerges in vast quantities. Ammonia, which will later prove vital for chemical reactions that lead to biology itself, swells the growing atmosphere. Even methane, another potent warming gas, joins this chaotic mix. The chemistry is startling in its intensity. These gases do not arrive gently or in measured quantities. They are expelled with the force of planetary passion, a violent release of what has been contained. The pressure differentials are extraordinary. Where hot gases meet the still cooling surface, chemical reactions occur that would seem violent to modern sensibilities. The atmosphere is literally being forged through this process, built up layer by layer from the offerings of the planet's interior. What makes this process so fundamental to life's eventual arrival is that it is selective. Not every element is released in equal measure. The light gases like hydrogen and helium escape to space, unable to be held by Earth's still developing gravity. But the heavier molecules, those that will interact with the emerging oceans and participate in complex chemistry, they remain. They condense, they react, they begin to create the chemical environment in which life will one day emerge. The water vapor is particularly significant. As more and more of it accumulates in this proto-atmosphere, the conditions begin to shift. Higher in the developing sky, where temperatures are slightly cooler, this vapor will eventually condense. When it does, it will fall as the first rains, and those rains will be transformative beyond measure. But that moment is still ahead in the timeline of our world. For now, the volcanic outgassing continues relentlessly. Day after day, year after year, century after century, the vents remain active. The atmosphere thickens. The chemistry becomes more complex. Ultraviolet radiation from the sun penetrates this early atmosphere, striking the accumulating gases and driving additional chemical reactions. New compounds form from the interactions of simpler elements. This is the genesis of atmospheric chemistry, the moment when Earth transforms from a lifeless ball of stone and fire into a world with an atmosphere of genuine complexity. The foundation is being laid for everything that will follow, from the first oceans to the first organisms. The chemical foundation for everything that would follow is being layered, breath by breath, into the sky above. Imagine the sound of rain unlike any on Earth today, endless, patient, relentless, falling from thick, dark clouds that had never known a clear sky. You are standing in a timeless space, suspended between the turbulent atmosphere of a young world and the evolving landscape below. 3,800,000,000 years before your time, the planet is entering a new chapter, one written in water. For millions of years before this moment, water vapor has been rising from the cooling surface and from deep within the Earth's interior. Volcanic eruptions have released endless plumes of steam along with other gases, and chemical reactions in the upper atmosphere have produced more water molecules. The air itself has become thick and heavy with moisture, pregnant with possibility. Now, as the surface temperature continues to decline, something remarkable begins to happen. The clouds thicken and darken. They grow heavier with each passing day, each passing year. The rain begins gently at first, delicate drops falling through the haze, but soon it becomes something far more substantial. Imagine water falling continuously, not in showers or storms as you know them, but in a perpetual curtain of precipitation. The rain falls for thousands of years without ceasing. It is not violent or destructive in the way you might imagine. Instead, it is patient and methodical, a planetary process of profound importance unfolding at its own ancient pace. The sound of this endless rain echoes across the desolate rocks and hardened lava plains below. It strikes stone that has never been touched by water before. Steam rises where the warm drops meet the still hot surface, creating a shimmering dance between sky and earth. Gradually, imperceptibly at first, the water begins to collect. It gathers in low places, in ancient basins carved by the violent geological processes of the preceding eons. These gathering places grow larger. Rivulets form as rain collects and flows downward, seeking the lowest ground. Small pools appear, then larger ones. The water is not pure. It carries minerals and salts leached from the rocks it touches. It carries dissolved gases from the atmosphere. It carries the chemical signatures of a world in transformation. Yet it is real water, precious water, the very substance that will eventually nurture all life. As the rain continues its patient work, the pools grow into bodies of water of remarkable size. Some are vast, stretching across what would one day become entire continents. The ocean basins are forming, but not all at once. It is a gradual, steady process. In some places, water collects more rapidly than in others. The shape of the emerging seas is determined by the topography of the cooling planet, by the irregular surface that was sculpted by heat and pressure, and the violent chemistry of a young world. The sound changes as the waters deepen. Where drops once fell on stone, they now fall on water. The surface of each growing ocean becomes textured with the impact of countless raindrops. Waves form, gentle at first, then more complex as winds move across the newly formed surfaces. The water begins to develop tides as the moon, which is much closer to Earth than it is in your time, exerts its gravitational pull on these emerging oceans. Life has not yet arrived. No fish swim in these waters. No plants grow along the shores. No creatures drink from these vast reservoirs. Yet the oceans are coming alive in their own way. Chemical reactions occur in the depths, where minerals from the Earth's crust interact with the water, and the gases dissolved within it. Thermal vents on the ocean floor release superheated water rich with minerals and energy. The oceans are becoming chemical factories, laboratories where the building blocks of life are being assembled. You can sense this in the stillness of this ancient time, in the patient rhythm of the endless rain. The world is preparing itself. The stage is being set for the greatest transformation any planet has ever undergone. Water, which fell from the sky as vapor and rose from the depths as steam, is now settling into its vast basins, creating an entirely new realm. The oceans that will eventually cover most of the Earth are here now, in these primordial moments, beginning their eternal dance with light and chemistry and time. In the gathering waters, the planet's greatest story is about to begin. The oceans of the early world are chemical laboratories of unimaginable complexity, where molecules dance and combine in patterns never before seen in the universe. As you drift through these primordial seas with your consciousness untethered from time, you witness a world fundamentally alien to anything your modern senses might recognize. The water itself seems to shimmer with an ethereal quality, catching light that filters down through an atmosphere still thick with volcanic gases and dust. These ancient oceans are not the clear, salty waters of today. Instead, they are murky, clouded with suspended minerals and metals leached from the young Earth's crust. Iron oxides paint the water in subtle shades of ochre and rust. Dissolved silica creates a faint luminescence, as if the entire ocean glows with internal light. The smell, if you could experience it, would be acrid and strange. Sulfurous compounds rising from hydrothermal vents mixing with ammonia from the atmosphere above, creating a chemical signature utterly foreign to modern life. As you settle into observation, you begin to perceive the deeper patterns emerging from this chemical chaos. The composition of these oceans is vastly different from what would come later. There is far less salt than the oceans you know, because the sodium chloride has not yet accumulated to its present concentrations. Instead, there are greater quantities of other minerals: iron, magnesium, calcium, and silica, all dissolving from the planet's fresh crust and pouring into the waters through countless rivers and submarine springs. Deep beneath the surface, you become aware of the hydrothermal vents, those dark chimneys where superheated water rich with minerals erupts from the Earth's interior. They are like beating hearts scattered across the ocean floor, pumping life-giving chemistry into the vast water column above. Around these vents, gradients form. Hot, mineral-rich water meets cold seawater, creating zones where temperature and chemistry shift dramatically over impossibly small distances. In these boundary layers, something remarkable begins to occur. Complexity emerges from simplicity. Simple molecules combine into more intricate forms. Hydrogen, carbon, nitrogen, and oxygen dance together in new configurations. Methane and ammonia swirl in invisible currents. Hydrocyanic acid forms and reformulates. Energy flows from multiple sources. Ultraviolet radiation penetrating from above. Thermal energy radiating from the vents below. Electrical energy from lightning crackling through the primitive atmosphere. This energy finds its way into chemical bonds, breaking them and creating new ones, establishing patterns that begin to repeat and build upon themselves. You sense the profound mystery of these waters. They are not yet alive, and yet they are not merely chemical reactions occurring at random. There is direction here, a subtle tendency toward increasing complexity. The oceans are becoming something more than they were. They are transitioning, molecule by molecule and reaction by reaction, toward conditions that will eventually permit life itself to emerge. Suspended in this ancient brine, you witness chemistry transforming into biochemistry. Organic compounds accumulate in small pockets and crevices, protected from the harsh, ultraviolet radiation above. Some of these molecules begin to exhibit properties that seem almost purposeful. They catalyze reactions, they store information in their structures, they make copies of themselves imperfectly, introducing variation into their offspring. They are not alive, not yet, and yet they possess qualities that will become essential to life. The ocean continues its slow transformation through millions of years, compressed into moments of your awareness. Iron oxide sediments settle onto the growing ocean floor, layering upon each other like memories. Minerals crystallize in specific geometric patterns that seem to encode information. The chemistry becomes more refined, more organized, more purposeful with each passing age. You drift through this cauldron of creation, witnessing the invisible choreography of atoms and molecules. In the depths, in the vents, in the sunlit shallows, in the dark abyssal plains, chemistry is performing its most intricate dance. The stage is being set for something extraordinary, something that will transform this sterile planet into a living world. The ancient oceans are patient teachers, writing the first chapters in a story of transformation that will eventually lead to forests and creatures, to consciousness and wonder. In this ancient cauldron, chemistry is writing its most important story. Descend with us to the dark depths of the early ocean, where the Earth's molten heart reaches out to meet the waters above. There is no light here, no sun to penetrate these crushing depths. Yet life finds a way to gather around warmth and chemical abundance in the most unexpected sanctuary of all. Picture yourself sinking slowly through the midnight waters, the pressure increasing with each fathom. Your eyes adjust to absolute darkness, and yet there is something glowing ahead. Shimmering columns of superheated water rise from cracks in the ocean floor, like ghostly apparitions dancing toward the surface. These are the hydrothermal vents, the Earth's way of offering its innermost riches to the waiting chemical systems above. The water emerging from these vents is not merely hot. It carries with it a treasure trove of dissolved minerals and compounds brought up from deep within the crust. Iron, manganese, sulfur compounds, hydrogen, and countless other elements create a mineral-rich solution that meets the cold ocean water in a collision of extraordinary chemistry. Where the two waters meet, there is no violence, only the gentle formation of mineral-laden clouds that billow and swirl in the darkness. The temperature gradient around these vents is gentle and gradual. Immediately at the vent opening, the water measures hundreds of degrees Celsius, hot enough to dissolve stone. But as you move away from the opening, the water cools progressively, creating zones of varying warmth. It is in these intermediate regions, where the temperature is warm but not scalding, that chemistry begins its most remarkable transformation. The minerals precipitating from the mingling waters create towering chimney structures, some reaching heights of several stories. These chimneys are built not by living creatures, but by purely chemical processes. The black mineral deposits coat the vents' exteriors, earning them the poetic name of black smokers. Around these thermal structures, a different kind of organization is emerging. In the slightly cooler water surrounding the vents, chemical reactions begin accelerating. Hydrogen gas reacts with carbon dioxide that has diffused down from the waters above. Sulfides combine with iron to form geometric crystals. But more importantly, these reactions begin to create small organic molecules. Simple chains of carbon atoms form, linking together in ways that require energy to maintain. The heat from the vents provides this energy, driving chemistry toward greater complexity. Consider the profound implications of this scenario. The vent water provides a constant source of chemical potential energy. The temperature differences drive reactions forward. The minerals create surfaces where molecules can collect and interact, protected from the chaotic mixing of the open ocean. It is almost as though the Earth has constructed a workshop designed specifically for chemistry to evolve toward complexity. Around these vents, the chemical systems are not yet alive, but they are becoming increasingly organized. Molecules form, dissociate, and reform in repeating cycles. Some chemical pathways prove more stable than others, persisting longer before breaking apart. Other pathways are less stable, disappearing as quickly as they form. There is a kind of chemical selection happening, where the most robust molecular configurations tend to persist while the fragile ones vanish. The vents maintain this chemical garden continuously. As long as the Earth's interior remains hot and the cracks in the crust remain open, the flow of mineral-rich water continues uninterrupted. Year after year, century after century, the same basic chemistry repeats, building upon itself. The simple molecules created at the vent gradually accumulate. Some travel with the currents into the broader ocean. Others remain in the privileged zones around the vents, where the special conditions persist. There is something deeply moving about witnessing this moment in Earth's history. The planet is approximately 3.5 billion years old in this chapter of our journey. The surface is still hostile, the atmosphere still toxic by modern standards. Yet in these hidden depths, the universe is conducting an experiment. Chemistry is being given every opportunity to become more elaborate, more self-sustaining, more capable of perpetuating itself. Around you in this darkness, the mineral clouds continue their gentle dance, swirling in the water like living things, though they are not alive, not yet. The temperature remains constant, the flow of minerals continues, and the slow organization of matter proceeds according to laws of physics and chemistry alone. In these thermal gardens, the choreography of chemistry is becoming ever more intricate. 4 billion years have passed since our journey began, and the character of our world has transformed beyond recognition. The violence that once defined our planet is slowly yielding to something gentler, something more patient. The relentless bombardment of asteroids and comets has ceased its terrifying symphony. The great impacts that scarred the young Earth have become memory, the collisions growing less frequent as the solar system settles into a more stable rhythm. Around us, the cosmos seems to take a deep breath, and we sense that something momentous is about to unfold. The Archean Eon begins approximately 3.8 billion years ago, and with it comes a palpable shift in Earth's ancient story. The temperature, which once soared to levels that would vaporize everything we know, begins a slow descent from its infernal heights. The surface no longer glows with the dull red of constant molten fury. Instead, patches of darker stone emerge, cooling and solidifying into something more permanent than the restless magma ocean that preceded it. These cooling surfaces will become the foundation of stable continents, the first truly lasting features of our world. As you float above this transforming landscape, you notice the atmosphere itself seems less hostile. The noxious clouds of methane, ammonia, and hydrogen still dominate the skies, still block out the distant sun with their thick, alien orange haze. Yet there is a quality to this atmospheric blanket that differs from before. It is becoming a container, a vessel that might eventually hold something other than chemical chaos. The greenhouse gases that warm the surface protect Earth from the sun's radiation in ways that will prove essential in the eons to come. The oceans, which emerged from the final release of water trapped in countless meteorites and comets, now cover most of the planet's surface. These are not the clear, blue waters we might recognize. They are murky, dark, and tinted with minerals leached from the cooling crust. Iron oxides give them an almost copper hue. Yet within their depths, despite their apparent barrenness, something extraordinary is occurring. The thermal vents that continue to erupt from the seafloor are no longer merely releasing heat into the void. They are creating microscopic environments where chemistry is performing its most delicate dance. In these underwater gardens of superheated water and mineral-rich fluids, molecules are bonding in increasingly sophisticated ways. Carbon and hydrogen and oxygen and nitrogen are finding each other in the dark depths, guided by the energy flowing from Earth's still restless interior. These interactions are becoming more organized, more purposeful, more intricate than anything we have witnessed before. The simple combinations are giving way to more complex molecules, chains and rings of atoms that seem almost to be reaching towards something greater. The first stable continents are beginning to form as the crustal plates, now becoming recognizable features of a dynamic world, collide and cluster together. These early cratons, the ancient hearts of continents, are small and simple compared to the vast landmasses that will eventually exist. Yet they represent a crucial milestone. They are islands of stability in a world that was previously defined entirely by flux and change. They will become the foundation upon which future continents will build. Around these emerging landmasses, the water continues its patient work of erosion. It dissolves minerals from the rock, carrying them into the oceans where they accumulate and transform. This process, though it will take eons to show visible results, is already beginning to change the chemical composition of the seas themselves. The oceans are becoming slightly less acidic, slightly more hospitable to the strange new molecules that are being synthesized in the thermal vents below. The energy that powers all of this transformation comes from three sources working in concert. The heat from radioactive decay deep within the Earth continues to drive geological processes. The chemical energy released by the reactions in those thermal vent systems provides the spark for molecular assembly. And faintly, distantly, the sun's radiation begins to play a role, its photons reaching through the atmosphere to influence surface chemistry. We stand at the threshold of a new age, one that will forever be marked by the emergence of life itself. Somewhere in the darkness of the ancient ocean, in the warmth of a hydrothermal vent, or the shallows of a tidal pool, something miraculous occurs. It is not a moment of thunder or lightning, not a dramatic flourish across the heavens, but rather a quiet, almost imperceptible transformation. The chemical soup of Earth's primordial waters, rich with hydrogen, methane, ammonia, and water vapor, begins to organize itself in ways that transcend mere chemistry. Organic molecules, born from the violent energy of lightning and ultraviolet radiation, start to arrange themselves into patterns that hint at something entirely new. You are witnessing the moment when the non-living becomes living, though there are no eyes to see it, no consciousness to comprehend the magnitude of what is beginning. These are not the complex creatures you might imagine. There are no fins or shells, no bodies or brains. Instead, there are simple proteins and lipids, self-replicating molecules enclosed in the most delicate of membranes. These are the prokaryotes, the ancestors of all life that will ever exist on this planet. Picture yourself descending deeper into these ancient oceans, past layers of sediment and stone, into environments where superheated water laden with minerals rises from the Earth's interior. Here, in these hydrothermal vents, the conditions are perfectly suited for this chemical awakening. The temperature gradients create natural gradients of energy. The minerals provide surfaces upon which molecules can organize and interact. It is in this context that life first whispers itself into existence. These earliest organisms are impossibly small, microscopic, beyond the comprehension of the human eye. A single cell measures perhaps a micrometer across. Yet within that infinitesimal space exists something that will define the next 4 billion years of planetary history. These cells possess the remarkable ability to absorb nutrients from their surroundings, to grow, to divide, and most crucially, to pass on information about how to be alive to their offspring. Feel the weight of time as you observe these creatures. They have no ambitions, no awareness, no sense of their own existence. They simply are, driven by the elegant simplicity of chemistry and physics. Yet somehow, in their simplicity, they are complex beyond measure. Each cell contains genetic material, a molecular instruction manual written in a language of 4 chemical letters. This language, this code, will remain essentially the same for all life that follows. As you watch, something remarkable happens. These microscopic organisms begin to thrive. They multiply, spreading through the oceans in numbers that boggle the imagination. Trillions upon trillions of these cells begin their patient work of existing, of consuming, of growing, of dividing. They are not aggressive or competitive in any recognizable sense. They simply follow the imperative encoded within their molecular structure: survive and reproduce. Some of these ancient prokaryotes begin to experiment with different ways of capturing energy. Some rely on chemical reactions within the water itself. Others, in a development of staggering importance, begin to use sunlight, capturing its energy through a process that will eventually become photosynthesis. This seemingly small innovation will reshape the entire planet. For now, these organisms are alone in the vast oceans, except for the chemical and mineral-rich environments that gave them birth. There are no predators because there is no prey. There is no competition because there is no concept of scarcity. There is only the endless, patient work of life itself, the simple act of existing and reproducing, spreading and diversifying. You might feel a sense of peace observing this moment. Despite the harshness of Earth's surface, despite the volcanic upheavals and the absence of oxygen in the atmosphere, despite the radiation pouring through an unprotected sky, life has found a way. It has emerged from complexity, from the marriage of chemistry and circumstance. It has crossed the threshold that separates the living from the merely chemical. These humble prokaryotes, invisible to any observer, unaware of their own existence, have accomplished something that will ripple forward through time itself. They have brought novelty to the universe, a quality that had never existed before. They have introduced the possibility of change, of adaptation, of evolution itself. The universe would never be the same, for consciousness, in its simplest form, had finally awakened. The microbes that drift through the ancient oceans are not content to simply exist. They begin to transform their world through the miracle of photosynthesis. These tiny cyanobacteria, barely visible to any eye that might have existed to see them, have discovered something remarkable. They have found a way to capture the energy of the sun itself, pulling it down from the heavens and storing it within their small bodies. This is not merely feeding. This is creation itself happening at the microscopic scale, a revolution whispered in the chemistry of life. As you float backward through time in your imagination, settling into this ancient world around 3 billion years ago, feel the weight of the change that is beginning. The atmosphere you would breathe, were you standing here, would seem alien to your modern lungs. There is almost no oxygen in this air. The sky hangs heavy with methane and other gases, casting an orange haze across the waters. The sun, though burning just as bright, seems somehow different when viewed through this ancient atmosphere, softer perhaps, or more distant in character if not in truth. But the cyanobacteria do not care about such things. They exist in vast mats, layering themselves in the shallow waters where sunlight can reach them. Generation after generation, they multiply, each one splitting and dividing, each one performing the same elegant chemical trick. They take water and carbon dioxide and transform them with sunlight into sugars and something else, something that for them is waste, something they release carelessly back into the world. Oxygen. At first, this oxygen changes nothing. The planet absorbs it readily, reacting with iron and stone, rusting the rocks in ways that will leave permanent marks in the geological record. These oxidized minerals will become the red rocks, the striped formations that geologists will one day find and marvel at, seeing in them the fingerprints of this great transformation. But the cyanobacteria continue their work, tireless and patient. They have all the time in the world, literally, and they use it well. Imagine now the passing of hundreds of millions of years. The oxygen accumulates. It builds slowly, generation by generation, each small breath of the cyanobacteria adding to the total. The rocks can absorb only so much. The chemical bonds that could be oxidized become saturated, and then, gradually, the oxygen begins to escape into the atmosphere itself. It rises, lighter than the heavier gases that dominated before, beginning its slow but inevitable climb toward dominance. This is not a gentle change for the world as it existed. The early life forms that thrived in this anaerobic environment, that had evolved every strategy to avoid oxygen because oxygen was poison to them, begin to struggle. The water becomes less hospitable. The very air, if they could perceive such things, becomes toxic. Many lineages of bacteria vanish, unable to adapt, unable to survive in this new world that their own relatives have created. It is a mass extinction, perhaps the greatest catastrophe life has yet experienced, brought about not by an asteroid or a volcano, but by life itself, by the simple act of photosynthesis repeated billions upon billions of times. Yet in this catastrophe lies the seed of everything that will come. The oxygen that kills the anaerobes does not kill all life. Some bacteria, clever and adaptable, begin to use this poisonous gas. They discover that oxygen, despite its danger, can be used in their own metabolism. It can be harnessed to extract even more energy from their food than before. They develop new pathways, new chemical processes. They do not merely survive the oxygenation of Earth, they thrive within it. The world changes colors, changes composition, changes fundamentally. The orange sky gradually becomes blue. The methane that once dominated the atmosphere fades. Over millions of years, layer by patient layer, the air transforms into something new. And this new air, toxic to the old world, becomes the foundation for everything that will follow. The great oxygenation is complete, and the stage is set for the magnificent diversity of aerobic life that will eventually fill every corner of the planet. What once was poison in the air became, in time, the breath that would sustain countless billions of lives yet to come. Patience is the greatest power in the history of our planet, and the humble cyanobacteria possess this power in abundance. Imagine yourself floating in the ancient seas, suspended in waters that are murky and warm, tinted with iron oxides that give them a rusty, copper hue. The sun filters through in diffused rays, casting everything in shades of amber and bronze. Around you, invisible to the naked eye, exist trillions upon trillions of microscopic organisms, so small that 1,000 could fit on the head of a pin. These are the cyanobacteria, and they are about to change everything. For nearly 2 billion years, these remarkable creatures have been slowly, methodically, patiently accumulating oxygen in the atmosphere and oceans. There is no rush in their work. There is no urgency. Generation after generation, they multiply and photosynthesize, drawing in carbon dioxide and water, using the sun's energy to fuel their existence. And with each metabolic breath, they release oxygen as a byproduct, a waste material from their perspective, into a world that has never known such a gas before. Feel the passage of time as it must have felt then, measured not in moments or days, but in epochs and eons. Millions of years pass like the turning of a single page. The cyanobacteria continue their work, undeterred, unchanged in their purpose. They are the architects of transformation, though they themselves do not know it, cannot know it. They simply exist. They consume, they produce, and they continue. In the early stages of this great oxygenation, The excess oxygen does not immediately flood the atmosphere. Instead, it reacts with iron dissolved in the oceans, combining with it to form iron oxide compounds that sink to the ocean floor. Layer upon layer of these iron-rich sediments accumulate, creating what we would one day call banded iron formations, geological monuments to this patient revolution. The ocean becomes a giant chemical reactor, slowly processing the oxygen output by cyanobacteria. But as millions of years give way to hundreds of millions of years, something profound begins to occur. The iron in the oceans becomes saturated, exhausted. There is only so much iron to combine with this relentless gift of oxygen. And so the oxygen begins to escape, rising through the water column, beginning to seep into the atmosphere itself. The composition of the air begins to change, almost imperceptibly at first, then with greater and greater significance. This is not a dramatic event in the moment. You understand. No explosions, no sudden transformations. Instead, it is a gentle, gradual alteration of the world's chemistry, playing out across millions of years in a rhythm that matches the slow pulse of geological time. The oxygen accumulates in the atmosphere fraction by fraction, percentage by percentage, building from nearly nothing to something that begins to matter, something that begins to change how the planet breathes. The early anaerobic organisms that dominated this world for so long begin to struggle. Oxygen is toxic to them, a poison that damages their cellular machinery, that disrupts their delicate chemistry. Some retreat deeper into the oceans, into sediments, into the few places where anaerobic conditions persist. But others evolve, adapt, change. Some organisms begin to use oxygen in their metabolism, discovering that it is not merely a toxin, but a tool, an energy source far more efficient than the chemical processes they had relied upon for so long. Picture the quiet majesty of this transformation. The cyanobacteria, these microscopic workers, continue their endless labor. They divide and multiply, age and die, their dead bodies sinking to the ocean floor, becoming sediment, becoming rock. And yet the work continues, carried on by their successors, their descendants, an unbroken chain stretching back nearly 3 billion years into the past. The sky, which was once a murky orange-brown or perhaps a pale gray, begins to shift. The balance of gases in the atmosphere, constant for billions of years, begins to alter. Rivers and soils take on new colors as minerals oxidize. The world is being prepared for something new, for creatures that will depend entirely upon oxygen to survive, for forests and animals, and eventually for us. Slowly, almost imperceptibly, the ancient world is being remade by the metabolic activity of creatures too small to see. In the shallow seas of the Archean world, strange mounds of stone begin to grow, layer upon layer, built by creatures barely larger than a grain of salt. Imagine yourself floating in warm, turquoise waters beneath an alien sky. The sun is dimmer than you remember, casting a softer glow across the landscape. Around you, in the tepid shallows where sunlight can still penetrate, structures rise from the seafloor like the most patient of architects at work. These are stromatolites, and they represent something profoundly beautiful, the first monumental creations of life itself. The builders are cyanobacteria, microscopic organisms so small that billions could fit on the head of a pin. Yet in their collective effort, across millions of years, they construct something magnificent. Watch as they work, though their labor unfolds at a pace imperceptible to human perception. Each bacterium captures sunlight and converts it into energy, releasing oxygen as a byproduct. As they photosynthesize, they also secrete sticky substances that bind nearby sediment particles together. Layer by layer, grain by grain, these microbes create a scaffold of their own making. The beauty of stromatolites lies in their architecture. They are not built according to any blueprint or conscious design. Instead, they emerge from the simple, repeated behaviors of billions of individual organisms following the same imperative: to grow, to reproduce, to seek light. The result is a structure of surprising complexity and organization. Some stromatolites form tall columns reaching toward the surface. Others spread as broad, dome-shaped mounds. The variations depend on the energy of the water, the angle of the sunlight, the composition of the sediment available. Within each layer, you can see the history of a moment in time. A thin band of darker material might represent a season of higher sediment input, when storms churned the seabed and carried more particles into the water. A lighter layer could mark a period of calm seas and clear water, when the cyanobacteria dominated the building process. Over thousands of years, these layers accumulate, each one a page in a geological diary written in stone. These structures serve a purpose beyond their own accumulation. The stromatolites create habitats, refuges where other primitive organisms find shelter and resources. Some bacteria live within the mucilaginous spaces, protected from the harsh, ultraviolet rays that would otherwise bombard an ancient Earth lacking any protective ozone layer. Stromatolites become entire ecosystems in miniature, supporting communities of interconnected lives within their porous stone bodies. The significance of stromatolites cannot be overstated. They are among the first visible evidence of life's presence on Earth. Before stromatolites, life existed only as microscopic films and biofilms, invisible to any eye that might examine the fossil record. But stromatolites are large enough, durable enough, and numerous enough to leave an unmistakable mark on the geological record. They are a declaration, written in stone, that life has begun to reshape its world. Imagine walking along the shores of these ancient seas. If you could somehow exist in that distant time, you would see mounds and columns rising from the water like submerged cities, built by creatures working in perfect synchrony, despite having no central coordination, no consciousness, no awareness of what they were creating. The work continues relentlessly, day after day, year after year, century after century. The stromatolites grow with agonizing slowness, yet their persistence is absolute. Over billions of years, these structures will cover vast areas of the seafloor. They will become so prolific that they will reshape the chemical composition of Earth's atmosphere itself. The oxygen they produce will accumulate, at first being consumed by chemical reactions with iron and other reactive elements. But eventually, oxygen will begin to accumulate in the air itself, changing everything that comes after. For now, in these ancient shallow seas, the stromatolites continue their patient work. They are monuments to persistence, to the power of collective action, to the remarkable capacity of life to shape and reshape the world around it. These humble structures would endure for billions of years, silent witnesses to the transformation of our world. Imagine a world where the sun itself seems distant and pale, its warmth unable to penetrate a global shroud of ice and snow. This is not a vision from some distant science fiction tale, but rather a reality that gripped our planet multiple times during the Proterozoic eon, stretching back between 200 and 600 million years before the present moment. You are traveling through one of these frozen epochs now, as the ancient Earth transforms into something almost unrecognizable beneath layers of crystalline ice that stretch from pole to equator without mercy or exception. Picture yourself standing on a vast frozen expanse where the horizon disappears into white nothingness. The temperature hovers far below anything experienced in modern times, a bone-chilling cold that would seem impossible to survive. Glaciers miles thick blanket the continents, their weight pressing down upon the land with unimaginable force. The oceans themselves have frozen over, their surfaces sealed beneath a crust of ice that extends nearly from shore to shore. This is Snowball Earth, a climate state so extreme that some scientists once questioned whether life could persist at all. Yet persist it must, and persist it does. Beneath this frozen veneer, in the deepest darkness of the ocean floor, life finds refuge in the most unlikely places, around hydrothermal vents, where the Earth's internal heat still radiates into the frigid waters. Simple microorganisms continue their slow metabolic dance. These are chemosynthetic bacteria, organisms that do not depend upon the sun's light for energy, but rather draw sustenance from the chemical energy released by the planet's geological processes. They represent one of life's most profound survival strategies, a reminder that existence need not rely on the photosynthesis that dominates the modern world. The triggering of these snowball Earth events likely began innocuously enough. Perhaps increased volcanic activity altered the composition of the atmosphere, or perhaps the arrangement of continents changed in ways that disrupted the circulation of ocean currents. Once begun, the process accelerates through a devastating feedback loop. As ice coverage increases, the planet's surface becomes more reflective, bouncing more of the sun's energy back into space. This causes further cooling, which causes more ice to form, which causes even more reflection. The cycle spirals downward into an ice-locked equilibrium that seems almost insurmountable. The duration of these frozen periods stretched across millions of years, each second an eternity of cold and darkness for any organism that might have clung to existence. The stromatolites, those ancient microbial mounds that had been growing steadily for eons, would have slowed their construction dramatically. The limited light penetrating through the ice ceiling and the reduced chemical nutrients flowing from the continents created an environment of almost total stagnation. Yet even in this frozen prison, life maintained its grip on existence. What finally broke these icy chains was the accumulation of carbon dioxide in the atmosphere. Volcanic outgassing continued relentlessly, releasing greenhouse gases that had nowhere to go due to the planet's frozen surface. Unlike in warmer times, when weathering processes lock carbon away in rocks, the glaciated Earth simply accumulated carbon dioxide year after year, century after century. Eventually, this buildup reached a critical threshold. Imagine the first cracks appearing in the ice, the first rays of warmth penetrating deeper into the planet's frozen exterior. The greenhouse effect, powered by billions of years of volcanic emissions, finally overwhelmed the reflective properties of the global ice sheet. The feedback loop reversed. Just as suddenly as it had initiated, ice began to melt, reducing reflectivity, allowing more warmth to penetrate, causing even faster melting. Within perhaps just a few thousand years, from a geological perspective almost instantaneously, the planet transformed from a frozen hell back toward more temperate conditions. Yet these catastrophic events, as devastating as they must have been, did not destroy life. Instead, they tested it to its absolute limits, and in doing so, forced evolution forward. The organisms that survived these periods possessed resilience and adaptability that would shape the trajectory of all life to come. These trials by ice were brutal selection pressures that eliminated the weak and favored the ingenious, the flexible, the determined. In the darkness and cold, life clings to survival, waiting for the warmth to return. Below the miles of ice, in the darkness of the ancient ocean, the pulse of life continues its eternal rhythm. Imagine yourself sinking deeper and deeper through the crystalline layers of ancient ice, descending through waters so cold that the molecules themselves seem to move in slow motion. Around you, the world appears lifeless, barren, an alien landscape frozen in time. The surface far above has become an impenetrable shield of white, cutting off the sun's warming rays for what will amount to millions of years. Yet as you continue your descent into the abyssal depths, you begin to perceive something remarkable. Life persists, not in triumph or abundance, but in quiet, determined survival. There are sanctuaries in this frozen world, refugia where the Earth's internal heat creates oases of warmth and chemical energy. Imagine discovering a hydrothermal vent on the ocean floor, a magnificent chimney of dark, mineral-rich water pouring forth from the planet's interior. The temperature here reaches hundreds of degrees, creating a dramatic contrast with the frigid water surrounding it. This extreme environment, which would seem utterly inhospitable to any living thing, becomes a beacon of life during these frozen epochs. Around these vents, creatures cluster together in defiant communities. Tube worms with no mouths and no stomachs, nourished entirely by the symbiotic bacteria living within their tissues, sway gently in the heated currents. These bacteria feast upon the chemicals emerging from the vents, converting the sulfur compounds into energy through a process called chemosynthesis. It is a form of life that requires no sunlight whatsoever, no photosynthesis, no connection to the world above. Here, in the total darkness of the deep ocean during Snowball Earth episodes, life has unlocked a secret pathway to survival that makes the sun irrelevant. As you move away from these hydrothermal gardens, you discover other refugia scattered throughout the ocean. Beneath the ice of polar seas, pockets of liquid water remain, and within these thin layers of ocean between ice and seafloor, extremophile organisms thrive. These are bacteria and archaea that have evolved to tolerate conditions that would destroy most life forms. They metabolize in ways foreign to the sun-dependent world above, breaking down organic matter that has accumulated over eons, drawing the last available energy from the frozen depths. The chemistry of these refugia becomes its own kind of miracle. Beneath the ice, without light penetrating from above, there are no algae to produce oxygen through photosynthesis. Yet life finds ways. Hydrogen sulfide rises from the vents, methane bubbles from sediments, ammonia and other compounds create pathways for chemical energy conversion. Microorganisms have evolved the astonishing ability to use these substances as their power source, building entire food webs from nothing but rocks, water, and heat. You might wonder how these creatures survive such extended periods of isolation. The answer lies in their extraordinary adaptation to dormancy and slow metabolism. Many microorganisms can reduce their activity to barely measurable levels, entering a state of suspended animation that allows them to endure for millions of years on minimal energy. It is as if they have learned to breathe so slowly that a single breath spans centuries. The remarkable truth is that these deep ocean communities remain connected to the world above through the most tenuous of threads. Eventually, when the ice begins to retreat and sunlight once again reaches the shallow seas, the organisms that sheltered in these protected spaces will emerge. They will repopulate the warming oceans, providing the foundation upon which entire ecosystems will rebuild themselves. The microorganisms that persisted in the darkness become the ancestors of the resurgence that follows. This moment in Earth's history teaches a profound lesson about life itself. It is not the largest or most powerful creatures that ensure survival during catastrophe. It is not the ones that depend upon the sun's constant blessing. Instead, it is the humble, the adaptable, the organisms that have evolved to extract life from the most extreme environments. They exist in the margins, in the deep places, in the chemical whispers of the planet's interior. The frozen world above holds no color, no warmth, no apparent movement. Yet below, in sanctuaries of heat and chemical abundance, life refuses to surrender. It shrinks and slows, and becomes patient beyond measure. It waits for the world to change again, knowing with an ancient, wordless certainty that change will come. Survival itself becomes a form of quiet heroism in this frozen world. As the ice recedes and warmth returns to our world, Life celebrates its survival with an explosion of new forms, each more complex than the last. The planet breathes again, and in that breath, something remarkable begins to stir beneath the ancient waves. Picture yourself suspended in the warm, shallow seas of what we now call the Ediacaran period. Approximately 635 million years ago, the sun filters through the clear water in dancing columns of amber and gold, illuminating a world utterly unlike anything you have ever witnessed. Here, in these tranquil waters, the first truly complex multicellular organisms float, drift, and anchor themselves to the seafloor. These creatures, which we have named the Ediacaran fauna, are unlike anything alive today. They are the pioneers of complexity, the first experiments in building bodies made of many cells working together. Some resemble quilted discs, flat and geometric, patterned like oriental rugs thrown across the ocean floor. Others stretch upward like feathered ferns, their fronds rippling gently in the ancient currents. Still others are shaped like tubes and spindles, anchored in place, filtering the nutrient-rich waters that flow around them. Imagine yourself swimming slowly among these ethereal forms. There is Dickinsonia, a creature that appears as a segmented oval, its body divided into repeating chambers. It moves slowly across the seafloor, perhaps grazing on the microscopic mats of bacteria and algae that carpet the ground. Above it floats Charnia, a frond-like organism that waves back and forth with the currents, its delicate arms extended to capture whatever nutrition drifts its way. And there, pressed against the rock, is Sprigina, with its distinctive curved head and body marked with parallel ribs that give it an almost insect-like appearance. These organisms are not yet fish or mollusks or jellyfish, though some may possess primitive qualities that hint at what their distant descendants will become. They represent something altogether different, a branch of the tree of life that would ultimately lead nowhere, organisms that would leave no modern descendants. Yet in their existence, they prove something crucial. Multicellular life can persist, can diversify, can grow larger and more complex. The water around you teems with an abundance that would have seemed impossible just a few million years before. Bacteria continue to thrive, now joined by early algae and strange protists. The oceans have finally recovered from the catastrophic cold, and life rushes forward to fill every available space. The oxygen produced by photosynthetic organisms has accumulated in the atmosphere over billions of years. And while the air is still far less oxygen-rich than it would eventually become, there is now enough to support the metabolic demands of these larger, more complex bodies. As your attention drifts across this alien seascape, you notice the remarkable stability. There are no predators here yet, no animals hunting other animals. These Ediacaran creatures exist in a sort of peaceful coexistence, competing for space and nutrients, but not for survival against predatory assault. They are the first tenants of a world freshly renovated after the ice ages, and they inhabit it with a gentleness that seems almost meditative. The light continues to filter down through the water, and you become aware of the slow passage of time. Seasons turn, year follows year. The Ediacaran fauna remains relatively unchanged for approximately 70 million years, a span of time so vast that it contains within it the entire history of modern humanity, thousands of times over. These creatures represent life's cautious venture into complexity, a proof of concept that larger bodies can indeed thrive. And yet, somewhere in the future, just beyond your perception, change is coming. In the depths of evolutionary time, new experiments are beginning. Some organisms will develop the ability to burrow into the seafloor, displacing the Ediacaran creatures from their homes. Others will develop hard shells and skeletons, a radical innovation that will change everything. Some will develop eyes and the ability to hunt. The peaceful coexistence of this strange menagerie is temporary, a brief and beautiful moment before the world transforms into something far more dynamic and dangerous. The stage is being set for the most dramatic act in the history of life on Earth. In the ancient oceans of the Ediacaran period, life creates forms so strange and beautiful that they seem drawn from dreams rather than evolution. You drift through waters that are warmer than those of today, watching as the seafloor transforms into something resembling a garden from another world entirely. The stage, set in ages past, now hosts players unlike anything that will ever walk or swim the earth again. Around you, the first truly complex organisms sway and pulse with an otherworldly grace. There are creatures called Dickinsonia, flat and oval like enormous pancakes, their bodies segmented with quilted patterns that ripple as they move across the muddy bottom. Some are larger than your outstretched arms, moving with a deliberate slowness that suggests neither urgency nor consciousness as you understand it. They are herbivores, perhaps, grazing on the bacterial mats that coat the ancient seafloor like invisible meadows of microscopic life. Floating nearby are the Charnia, delicate structures that resemble nothing so much as enormous feathers or fronds, anchored to the bottom yet swaying in the gentle currents. Their bodies are built from repeated units, creating a fractal beauty that seems almost impossible in its mathematical perfection. Scientists will marvel at these creatures millions of years hence, debating whether they were animals at all or something entirely different, a branch on life's tree that would never bear fruit. The Ediacaran garden hosts stranger residents still. There are creatures called Sprigina that possess what might be interpreted as a head and a tail, segmented bodies that hint at movement and direction. Perhaps they crawled, perhaps they simply lay still. Their purpose remains veiled in time's deep fog. And then there is Parvancorina, armored with a shield-like carapace, suggesting that even in this peaceful garden, some creatures felt the need for protection, though from what threat remains unknown. You notice the water around you is filled with drifting particles, organic snow from the layers above, and the creatures of this realm seem to exist in a kind of suspension between feeding and simply being. Many have no obvious mouths, no clear mechanisms for consuming food. They may absorb nutrients directly through their skin, or perhaps they host symbiotic partners invisible to your eye, tiny organisms that photosynthesize and share their bounty. The ocean in this era is fundamentally different from what you have witnessed before, richer in oxygen, more hospitable to complex life, yet still strange in ways that defy modern biology. As you move through this realm, you become aware that you are witnessing something precious and fragile. These creatures are soft-bodied, vulnerable to decay, to predation, to the infinite small disasters that befall life. Most will leave no trace. Yet here and now, in this moment stretched across millions of years, they thrive. They reproduce. They grow. They interact with one another in ways you can barely fathom. The Ediacaran fauna represents life's first major gamble, its first attempt at building complexity beyond the simple and the microscopic. Around the quilted bodies of Dickinsonia, you see smaller organisms, creatures mere millimeters across, and you realize that even now, even in this ancient garden, there is a hierarchy. There is predation, competition, the beginning of the intricate relationships that will define life's future. The Ediacaran garden is not a paradise of pure peace, but rather an ecosystem in its infancy, learning the harsh lessons of survival. The light filtering down from the surface above is dimmer than it would be in future ages, the sunlight scattered by a different atmosphere, creating an eternal twilight in these waters. The creatures seem perfectly suited to this half-darkness, their strange forms and minimal eyes suggesting they navigate more by chemical signals and touch than by sight. You linger here as eons pass in moments, watching the slow dance of Ediacaran life. These organisms will not survive. The drama to come in subsequent ages will render this entire fauna obsolete, pushing them into extinction so complete that for millions of years, humans will debate whether they were truly alive at all. These creatures are temporary, destined to vanish, but their existence proves life's infinite creativity. Suddenly, in terms that geological time knows, the oceans of Earth explode with innovation and diversity, unlike anything seen before. You float through the warm, shallow seas of this ancient world, 541 million years ago, and the transformation is breathtaking. The waters shimmer with movement in every direction, a symphony of forms and possibilities that seem to materialize from the depths, as if creativity itself has awakened from a long slumber. Picture yourself drifting through these primordial oceans, suspended in the currents as strange and wonderful creatures emerge around you. Where once the seafloor held only simple organisms and soft-bodied animals, now there is exuberance. Trilobites, those armored ancestors with their segmented bodies and compound eyes, scuttle across the bottom like underwater explorers discovering a new world. They possess something revolutionary: hard shells, protective plates that shield their bodies from predators and the harsh pressures of the deep. You watch them move with surprising grace, their appendages working in careful coordination, and you realize you are witnessing one of life's great innovations. The skeleton, the internal support system that allows creatures to grow larger and more complex. The waters around you pulse with other extraordinary forms. Strange creatures called anomalocarids drift through the depths, predators unlike anything alive in your own time, with their circular mouths and lethal appendages reaching out to capture prey. They are the dragons of this ancient ocean, imposing and efficient hunters who dominate their world. You observe them with a sense of awe and wonder, understanding that these fierce creatures will one day vanish completely, leaving only their fossils as whispers of their existence. Alongside them swims Opabinia, a five-eyed creature that seems almost fantastical in its appearance, yet which is entirely real, entirely functional in this flourishing ecosystem. It hunts with a flexible appendage that extends before its mouth, snatching prey with remarkable precision. You marvel at how different life has become in such a relatively brief span of time. The sheer variety is staggering, as if nature has suddenly gained confidence in its own designs and is experimenting with every possibility that comes to mind. Above you, in the shallower waters where sunlight penetrates the surface, other marvels unfold. Primitive fish begin to appear, the first creatures with backbones, with the basic structures that will eventually evolve into the great lineages that lead toward you. These early fish are modest in appearance, small and simple compared to their distant descendants, yet they carry within them the blueprint for everything to come. You sense the profound significance of this moment, though you cannot name it yet. The seafloor itself transforms into a garden of life. Sponges attach to rocks in great profusion, filtering nutrients from the water. Primitive corals begin to build their first structures. Arthropods of every imaginable design crawl and swim through the ocean, testing new body plans, new ways of surviving and thriving. Each innovation builds upon the last. Each new form creates new opportunities for others to evolve and exploit. You feel the energy of this moment, the sense that life is discovering itself with unbridled enthusiasm. In a geological moment, in what might take only 10 or 20 million years, the oceans transition from a relatively simple collection of organisms to a complex, interconnected web of hundreds of different forms. Major animal phyla appear in the fossil record, establishing the fundamental body plans that will persist for hundreds of millions of years. The cnidarians, mollusks, arthropods, echinoderms, chordates, the great divisions of animal life all announce themselves during this remarkable time. You drift through these waters with mounting wonder, understanding that you are witnessing a turning point in the story of life on Earth. The foundation for everything that comes next is being laid right now, in these warm seas, by creatures both bizarre and brilliant. The Cambrian explosion is the moment when life discovers that it can be countless things, and it seizes this possibility with brilliant enthusiasm. Among the strange creatures of the Cambrian seas swims a hunter unlike any before it, with eyes that can see and limbs that can grasp. Picture yourself drifting through these ancient waters, 500 million years distant from your own time, suspended in a realm where the light filters down in soft, ethereal rays. The mud below is thick and rich with the writhing bodies of smaller creatures, and moving through this twilight realm comes something extraordinary. Anomalocaris emerges from the shadows like a dream made flesh, a creature that would dominate these primordial oceans with a mastery no organism had ever possessed before. Your vision draws closer to this remarkable hunter. It is perhaps a meter long, a sleek and segmented form that moves with surprising grace through the water. The body is composed of broad, flat segments, each one capable of undulating in perfect rhythm with its neighbors, propelling the creature forward in waves of controlled motion. There is an almost hypnotic quality to its movement, a sinuous gliding that seems to make no effort at all yet carries tremendous power. But the true marvels of Anomalocaris are the features that make it such an efficient predator. At the front of its body, two remarkable appendages emerge, long and flexible structures lined with spines. These are not legs, not quite, but something entirely new in the history of life. They are grasping limbs, designed with precision to snatch prey from the surrounding water and pull it toward the creature's waiting mouth. There is an intelligence implied in their design, a purposefulness that speaks to the evolutionary journey that led to this moment. And then there are the eyes. Pause for a moment and consider what this means. Before Anomalocaris, most creatures of the Cambrian seas possessed only simple, light-sensitive organs, able to detect little more than the presence or absence of illumination. But Anomalocaris possesses true compound eyes, complex organs of remarkable sophistication. These eyes sit on the sides of its head, large and multifaceted, capable of perceiving not just light but form, movement, and detail. They are hunters' eyes. With them, Anomalocaris can see the Cambrian world with a clarity that its prey cannot match. Feel the intensity of this moment. Around Anomalocaris swims the abundance of Cambrian life. Trilobites scuttle across the seafloor, their segmented bodies armored and defensive. Strange predatory worms with bristling tentacles probe the mud. Rounded creatures that might be distant ancestors of today's jellies pulse gently through the water. Anomalocaris observes all of this with those remarkable eyes, calculating, assessing, choosing. When it strikes, it is sudden and devastating. The grasping appendages flash forward with speed that the prey cannot hope to match. The spines lock around a struggling trilobite or a soft-bodied creature trying to flee. There is a moment of intense struggle, but it is brief. The prey is drawn inexorably toward the creature's mouth, and the hunt is complete. Anomalocaris has fed, and in doing so, it has demonstrated something revolutionary in the history of life. You are witnessing the birth of a concept that would echo through 4 billion years of evolution. This is specialization. This is the emergence of the dedicated predator, an organism shaped by evolution specifically to hunt and kill other creatures. Before this, there was consumption, certainly, but not like this. Not with eyes designed to see prey, with appendages crafted to capture it, with an entire body plan optimized for the hunt. This innovation will cascade through time. It will drive the evolution of armor and speed in prey species. It will fuel an evolutionary arms race that would never cease, a relentless cycle of hunter and hunted, each pushing the other toward greater sophistication, greater complexity. Predators will diversify into countless forms. They will grow larger and more fearsome. They will develop weapons of astonishing variety, and their prey will evolve in response, faster, harder, cleverer, locked forever in this dance of survival. Anomalocaris is the first of its kind, but it will not be the last. In a very real sense, all of the fearsome hunters that would come after, all of the dinosaurs and saber-tooths and great white sharks and wolves and eagles, all trace their lineage back to this moment. Predation is born, and with it, an endless evolutionary arms race that would shape the history of life. A new architectural possibility is discovered by evolution, an internal spine that provides support and protection for delicate organs within. Imagine yourself floating through the ancient seas of the Cambrian period, suspended in waters that shimmer with an otherworldly light. The violent arms race that began with the first predators continues to reshape life's possibilities, and now something revolutionary is emerging from the depths. Around 505 million years ago, in these prolific oceans teeming with bizarre arthropods and strange, soft-bodied creatures, small fish-like animals begin to appear in the fossil record. These are the agnathans, jawless fish, and they represent perhaps the most profound turning point in your own personal history. You are witnessing the moment when your most distant ancestors first developed the very feature that defines you and all your vertebrate cousins, an internal skeleton. Before this innovation, life had relied on external armor and exoskeletons. The trilobites wore their skeletons on the outside, hardened shells protecting soft bodies within. But these early fish discovered something entirely different. Deep within their bodies, a flexible rod of cartilage begins to form. This notochord, as scientists would eventually call it, runs along the length of their bodies like a hidden treasure, supporting their muscles and protecting the delicate nerve cord that runs through its center. This nerve cord is the ancestor of your spine and brain. Picture these pioneering creatures moving through the ancient seas with graceful undulation. They are small, no more than a few inches long, with rounded bodies and rudimentary fins. They have no jaws, no teeth, no complex structures at all, and yet within their humble forms lies a revolutionary design principle. By moving their skeleton inside rather than outside, they achieve a flexibility that rigid armor could never provide. They can bend and twist with fluid grace, responding instantly to threats and opportunities alike. The waters around them are still populated by the fearsome predatory arthropods, the ancient killers who continue to hunt anything smaller than themselves. These new fish, with their internal support systems, move more efficiently, more gracefully, more adaptively than their contemporaries. The internal skeleton proves to be not merely a structural innovation, but a competitive advantage in the never-ending struggle for survival. As you observe these creatures drifting through the ancient currents, you begin to understand what you are witnessing. This is not merely the appearance of a new body plan. This is the birth of a possibility tree that will grow and branch for 500 million years into the future. The internal spine provides a framework upon which endless variations can be built. From this simple cartilaginous rod, vertebrae will eventually develop, creating articulated columns of bone. Ribs will eventually sprout to protect vital organs. Fins will evolve and transform into limbs. Gills will become lungs. And the nerve cord protected within this spinal column will become ever more complex, eventually developing into the brains of fish, then amphibians, then reptiles, then mammals. The early agnathans have no inkling of their own significance. They simply swim through the Cambrian seas, feeding on tiny organic particles and small organisms, going about the business of survival and reproduction. Yet they carry within them the architectural blueprint that will eventually produce some of the largest creatures ever to exist. They hold the promise of the towering dinosaurs and the mighty whales. They carry the potential for primates and humans, and all the conscious awareness that consciousness will eventually bring. You watch as these simple fish continue their quiet revolution. Some will develop more sophisticated fin structures. Others will eventually gain jawlines, creating true fish that would dominate the seas for the next several 100 million years. They are utterly ordinary in appearance, these first vertebrates, and yet they are extraordinary in their potential. The ecosystem continues its relentless churn around you. Predators hunt, prey flee. Extinction claims some species while new innovations arise in others. But in the midst of this ancient competition, your own lineage has just taken a remarkable step forward. Something simple and elegant has been discovered. Something that will prove to be one of evolution's greatest innovations. In these humble fish, the blueprint for humans, dinosaurs, and all vertebrate animals is being carefully sketched by the hand of time. The oceans grow ever more populated and diverse, a living tapestry of forms and colors that rivals any garden on land. Imagine yourself floating weightlessly through warm ancient seas, suspended in crystalline waters that teem with an astonishing array of creatures. The Ordovician period has arrived, an era of remarkable flourishing that builds upon the foundation laid in the Cambrian before it. The stage of life has expanded, and new players are constantly emerging to fill ecological niches that barely existed millions of years prior. Around you, trilobites continue their ancient dance, their segmented bodies glinting in the filtered sunlight that penetrates from above. These armored arthropods have thrived through the transition from the Cambrian, and now they proliferate in dizzying numbers, occupying every corner of the seafloor. Some remain small and delicate, while others grow to impressive sizes, predators and scavengers alike, their compound eyes surveying the bustling microcosm of existence that surrounds them. They burrow through sediment, crawl across rocky surfaces, and swim with surprising grace through the water column. But the trilobites are no longer the dominant story. The true revolution unfolding in these seas belongs to the mollusks, those soft-bodied creatures that have learned to build magnificent shells around themselves. Cephalopods begin to appear, distant ancestors of the octopuses and squids that will one day become masters of the ocean. These creatures possess a cunning that the rigid-bodied arthropods cannot match, a flexibility of form and behavior that hints at intelligent possibilities yet to come. Bivalves and gastropods proliferate as well, creating a symphony of shell forms that will echo through millions of years of evolution. Drifting through the currents, you notice something extraordinary taking shape. The fish that emerged in the previous age are diversifying rapidly, and among them, a revolutionary innovation is spreading. Jaws have appeared. Imagine the impact of this simple development. Jaws mean feeding efficiency beyond anything previously possible. Jaws mean the ability to grasp and tear and process food in new ways. The first fish with true jaws, the acanthodians, are beginning to dominate the waters, their mouths opening wide to capture prey that once might have escaped. These jawless fish, descendants of those humble filter feeders who bore the blueprints of your own skeleton, are transforming into something more capable, more aggressive, more efficient. Some grow spines along their bodies, defensive structures that speak of an increasingly competitive marine environment. Others develop specialized fins that allow for more precise maneuvering through three-dimensional space. These adaptations seem small in isolation, but they represent the opening of doors that will remain open for hundreds of millions of years. The diversity extends beyond the swimming creatures. Corals are beginning to establish themselves on the seafloor, laying the foundation for reef systems that will eventually become the most biodiverse ecosystems on the planet. Bryozoans, those colonial creatures that will eventually form entire limestone structures, are beginning to spread. Starfish and sea urchins are diversifying, their radially symmetric bodies perfectly suited for life on the bottom of the sea. Floating above all of this, you sense the invisible hand of evolution guiding each transformation, each innovation, each new form that emerges. There is no consciousness directing this process. No grand designer creating intentional change. Instead, there is only the simple mathematics of survival and reproduction, the relentless pressure of competition for food and space, the random mutations that occasionally produce something new and useful. When an innovation proves advantageous, it persists. When it proves neutral or detrimental, it fades away. The process is mechanical, yet the results are breathtaking. The waters around you shimmer with possibility. Every creature swimming past has survived countless challenges, inherited the tested blueprints of millions of generations. Every adaptation visible here, from the brilliant colors of these early fish to the complex geometry of the trilobite's eye, represents countless small victories against extinction. Time moves on, and the Ordovician seas continue their slow transformation, life becoming increasingly intricate and interdependent. Life has found its rhythm in the seas, and evolution is dancing to its beat. The abundance of the Ordovician world suddenly faces a test it is not prepared to endure, a cataclysm that will reshape the ocean forever. You drift through waters that have known only flourishing for millions of years, watching creatures move through their daily existence unaware that the rhythms sustaining them are about to shatter like glass beneath an invisible hammer. The temperature begins to drop, slowly at first, so gradually that no single organism notices the change from one day to the next. But across thousands of years, the warmth that has cradled life in tropical abundance begins to drain away. Great ice sheets form at the poles, spreading like frozen fingers across the continents. This is no natural oscillation of seasons. This is a fundamental shift in the planet's temperature, and the oceans respond with consequences that echo through every living thing dwelling within their embrace. As the water cools, something profoundly troubling occurs in the chemistry of the seas themselves. The oxygen that life depends upon begins to disappear from vast regions of the ocean floor. Stagnant, airless zones expand in the depths, creating dead spaces where nothing can survive. These oxygen-free waters spread like a shadow, cutting off retreat routes and suffocating creatures that have nowhere else to go. The abundant reefs that have dominated the shallows begin to break apart, crumbling under stress and changing conditions that exceed the tolerance of the organisms building them. You witness the trilobites, those resilient armored wanderers that have thrived for so long, struggling to adapt. Some retreat to deeper waters seeking refuge, only to find those depths increasingly hostile and lifeless. Others cling to shrinking habitable zones, pressed closer together in desperation, competing for space in an ever-shrinking world. The graptolites, delicate colonial creatures that have danced through the currents, see their numbers dwindle catastrophically. Species that numbered in the thousands vanish in geological eye blinks. The filter feeders that have siphoned life from the plankton-rich waters find their food sources collapsing as primary productivity crashes. Brachiopods, those humble cup-shaped creatures with their waving tentacles, fade away by the millions. Mollusks vanish from regions where they once thrived. Even the mighty armored fish, those early pioneers of vertebrate innovation, face severe pressure. Nearly 85% of all marine species will disappear before this extinction event concludes. The oceans that once seemed infinite in their capacity to support life reveal themselves suddenly, shockingly vulnerable. There is a strange quiet that descends upon the waters during this time. The constant rustling movements of countless creatures, the biological symphony that has filled the depths, diminishes to something sparse and uncertain. Survivors cluster in small refuges, in pockets of relatively stable conditions where temperature and oxygen still permit existence. These are the fortunate ones, the lucky inheritors of circumstances that allow them to persist while their countless relatives perish. The speed of this extinction is what makes it so devastating. Though it unfolds across tens of thousands of years from a human perspective, in geological time, this is catastrophic. sudden and overwhelming. The evolutionary innovations that took millions of years to perfect become liabilities. The specializations that made creatures perfectly suited to Ordovician abundance become death sentences when that world transforms beyond recognition. Complexity that once conferred advantage now becomes fragility. You sense the weight of this moment, the profound sadness embedded in the numbers. Life has not yet learned that it can be fragile, has not yet accumulated the wisdom that diversity requires resilience. The first mass extinction in Earth's history demonstrates a harsh lesson written in the extinction of species. The stability upon which life builds its dreams is temporary. The abundance that seems eternal can vanish. The world that supports such magnificence can turn hostile with shocking speed. Yet within this devastation lies something seeds of transformation. The species that survive emerge into a suddenly emptied world, a stage cleared of competitors and predators alike. The extinction, though tragic and immense in scale, creates opportunity. The vacant ecological spaces will attract new innovations, new adaptations, new ways of being. Death on this scale is both ending and beginning, a reset that will create space for new innovations to flourish. In the aftermath of catastrophe, life demonstrates a remarkable capacity for renewal and adaptation. Picture yourself standing in a world transformed, where the dust has finally settled and the planet begins to breathe again. The oceans, once choked with debris and toxins, gradually clear. The atmosphere shifts. Sunlight returns with increasing intensity to the recovering landscape. And in this returning light, something miraculous unfolds. The survivors, those hardy organisms that persisted through the darkness, find themselves in a strangely empty world. Where there was once competition fierce and unrelenting, there are now vast spaces waiting to be filled. Imagine moving through these transformed ecosystems as a gentle observer, watching as life, resilient and ingenious, begins to claim the newly available niches. It is as if the planet itself is taking a deep breath and exhaling possibilities. Small creatures that had hidden in burrows and crevices emerge cautiously into the changed world. Insects, already incredibly adaptable, begin to diversify in remarkable ways. Some grow larger in the absence of competition, their descendants eventually filling roles that larger creatures once occupied. Observe how a single lineage, given time and opportunity, can branch and rebranch, each descendant subtly different from its siblings, each exploring a different corner of the newly available space. In the oceans, similar patterns emerge. Surviving fish species multiply and specialize. Some develop new hunting strategies. Others adapt to different depths and temperatures. The ammonites, those beautiful spiral-shelled creatures, vanish entirely, but other mollusks rise to take their place. New forms of nautilus and squid evolve to fill the ecological roles left vacant. The oceans, within a few million years, teem with life once more, yet profoundly different from what came before. Move your awareness to the land, where the changes are perhaps most dramatic. The dinosaurs are gone, but their place is not empty for long. Small, furry creatures that survived in the shadows of the reptilian giants now have their moment. Mammals, previously insignificant, begin their slow ascent. Some grow larger. Some develop specialized diets. Some take to the trees. Some, over vast stretches of time, will eventually dominate the landscape in ways that seemed impossible mere millions of years earlier. Feel the passage of time as you witness these transformations. Thousands of generations pass. The early mammals are tiny, mouse-sized creatures scurrying through recovering forests. Then, gradually, across millions of years, you see their descendants becoming larger, more diverse, more specialized. This is not rapid change, but patient, persistent innovation. Evolution works its quiet magic, and every small variation that helps survival becomes amplified across generations. Notice how the recovery is not a simple return to what was. Life does not merely rebuild the old world. Instead, it creates something entirely new. The plants adapt to fill new niches. Flowering plants, already established, diversify spectacularly. The insects that pollinate them evolve in tandem, creating relationships of extraordinary intricacy. It is a dance of mutual adaptation, with each partner responding to the innovations of the other. Consider how the planet itself participates in this recovery. The volcanic activity gradually subsides. The atmosphere continues to stabilize. Weathering of rocks slowly rebuilds the soil. Each of these planetary processes creates conditions in which life can flourish more abundantly. The physical world and life itself are locked in constant conversation, each shaping the other across deep time. This recovery teaches us something profound about life itself. Organisms are not fragile in the way we might imagine. They are astonishingly creative, capable of exploring countless different solutions to the fundamental problem of survival. Where extinction creates emptiness, evolution rushes in to fill it with innovation. The genetic variation within surviving populations becomes the raw material for spectacular diversification. Watch as the recovering world becomes more complex, more intricate, more interdependent. New relationships form between predator and prey, between plant and pollinator, between organism and environment. Life does not simply persist. It flourishes, it innovates, it reaches toward ever greater sophistication. In this slow, patient process of recovery, we witness evolution at its most creative. The terrible loss becomes an opportunity for renewal, and from the ashes of extinction, life emerges transformed. Extinction, terrible as it is, becomes a teacher that drives evolution toward ever greater complexity and innovation. For billions of years, life has been confined to the oceans, but now evolution is whispering a new possibility. What if life could live where water touches stone? Imagine yourself standing at the edge of an ancient shoreline during the Silurian period, roughly 440 million years ago. The sun hangs low and heavy in an oxygen-rich atmosphere. The water around you is warm and teeming with life. Armored fish dart through kelp forests, trilobites scuttle across the seafloor, and nautiloid cephalopods prowl the depths with intelligence and grace. But your gaze turns inland, toward the barren rocky plains that stretch beyond the waterline. For eons, those lands have been utterly lifeless, a gray and desolate expanse where no creature dares to venture. Yet something is changing. Something remarkable is beginning to stir in the margins between water and land. Life, driven by the relentless pressure of competition and the scarcity of resources in crowded oceans, is beginning to experiment with the impossible. Picture the first primitive plants creeping across those rocky shores. They are not the towering trees or flowering plants you know today. These are humble, almost translucent organisms called rhiniophytes, with simple tube-like structures called vascular tissue, nature's first water delivery system. Imagine the engineering challenge. How to draw moisture from the ground and transport it upward against gravity without the buoyant support of water. These early pioneers are solving that puzzle, one adaptation at a time. Their roots, barely worthy of the name, grip into crevices and crumble stone into soil. Their delicate stems, strengthened by lignin, stand defiantly against the wind and the drying sun. Feel the revolutionary nature of this moment. For the first time in Earth's history, green life is creeping onto bare land. These plants are not simply surviving in this harsh new world. They are transforming it. As they grow and die, they accumulate. They trap sediment. They create pockets of moisture in the once lifeless rock. Slowly, grain by grain, stone by stone, they are building soil itself. They are literally constructing the foundation upon which future ecosystems will flourish. The Silurian atmosphere is becoming ever richer in oxygen, a waste product from all this photosynthetic activity. Breathe that air in your imagination. It is invigorating, full of potential energy waiting to be tapped. The concentration of oxygen is climbing steadily, creating new possibilities for respiration, for metabolism, for the kind of active, dynamic life that the future will demand. Watch as other organisms begin to tentatively explore these newly habitable margins. Tiny arthropods, early ancestors of insects and spiders, venture onto the damp soil. They are small, primitive creatures with simple needs, but they are brave pioneers nonetheless. They feed on the decomposing plant matter, on the fungi that are beginning to colonize this frontier. Some shelter beneath the first fragile plant canopies. These early terrestrial arthropods are not yet flying, not yet fully adapted to land, but they are learning. Each generation gains new capabilities, new tolerances, new strengths. Consider the profound challenges these creatures face. The ocean provides buoyancy, pressure, temperature stability, and dissolved oxygen. Land offers none of these comforts. The sun's rays beat down with unfiltered intensity. The air dries the skin. The wind can topple the unwary. Gravity pulls with full force, no longer cushioned by water's embrace. Yet life persists. Life adapts. Life finds ways forward through the problem, around the problem, over the problem. The Silurian period represents a threshold, a doorway, a moment when life itself is taking its first tentative steps toward an entirely new frontier. Sense the pioneering spirit of these ancient organisms. They carry within them the accumulated wisdom of 3 billion years of marine evolution. But they face challenges fundamentally different from anything their ancestors encountered. No blueprint exists for this adventure. There is only trial and error, extinction and survival, failure and occasional triumph. The oceans have grown crowded. Resources are competed for fiercely. And so life, as it always does, seeks new possibilities. It reaches toward those barren shores with quiet determination. The waters lap against the stone, and in that eternal zone of transition, transformation begins. The conquest of land is beginning, slowly and patiently, one adaptation at a time. The oceans of the Devonian period are a kingdom of fish, a diversity of forms and adaptations that makes this age the golden age of aquatic life. Imagine yourself descending through crystal waters, surrounded by creatures unlike anything that exists in your modern world, yet bearing the unmistakable marks of a lineage that will one day walk upon dry land. Around you swims an extraordinary menagerie of forms. The armored fish, those magnificent placoderms, dominate the shallow seas with their bodies encased in thick plates of bone, like living fortresses gliding through the depths. Some grow to tremendous sizes, apex predators with powerful jaws designed to crush and tear, commanding respect and fear from smaller creatures that scatter at their approach. Yet even these dominant creatures will vanish entirely before this period ends, leaving no descendants, their reign temporary despite their magnificence. But there are others, destined for far greater futures. The sharks cruise through these waters with their sleek, efficient bodies, already perfected by evolution for the predatory life they lead. Their flexible skeletons of cartilage allow them a grace that the armored fish cannot match, and they glide with an elegance that seems almost effortless. These ancient sharks are recognizable cousins to the creatures that will continue swimming through Earth's oceans for hundreds of millions of years more, survivors of multiple extinction events, testament to the perfection of their design. Then there are the fish that seem caught between two worlds, neither fully of the water nor truly of the land, yet absolutely crucial to understanding what comes next. These are the tetrapods, and they represent a threshold moment in the history of life itself. Imagine the shallow waters of Devonian swamps and estuaries, where rivers meet the ocean and oxygen grows scarce. In these challenging environments, certain fish developed something revolutionary. They grew limbs. Watch as creatures like Eusthenopteran move through the murky water, their fins beginning to transform into something more than mere paddles. The bones within are becoming increasingly like arms and legs, rearranging themselves into configurations that could support a body on land. These are not yet creatures that walk, but they are practicing, experimenting with movement on muddy bottoms, perhaps pulling themselves across exposed banks when water levels drop. Consider the extraordinary Tiktaalik, a creature that seems designed specifically to blur the boundary between fish and tetrapod. Its body is flat and crocodile-like. Its front appendages possess both fin-like properties and proto-arm capabilities. It can prop itself up on these limbs, perhaps resting in shallow water or dragging itself across exposed ground. This animal represents a perfect transitional form, a living bridge between worlds, showing us precisely how the conquest of land might occur. The Devonian world is dynamic and changing. Massive fish with specialized feeding strategies fill every niche. Some are filter feeders, straining tiny organisms from the water. Others are bottom dwellers, carefully probing soft sediments for hidden prey. Still others are swift hunters, built for speed and precision in the open water. The diversity is almost overwhelming, a testament to the creative power of evolution working across millions of years. Beneath the waters, these fish are adapting to every possible lifestyle. Some develop lungs alongside their gills, allowing them to gulp air at the surface when water oxygen becomes depleted. Others become specialized hunters with increasingly sophisticated eyes and sensory systems. The arms race of predator and prey drives constant innovation, constant modification, constant improvement. But what makes the Devonian truly special, what makes it magnificent beyond measure, is the knowledge of what is coming. These fish with their developing limbs, these creatures learning to breathe air, these residents of this golden age are the ancestors of every vertebrate animal that will ever walk on land. From these humble experiments in shallow water will eventually evolve dinosaurs and birds, mammals and humans, countless forms of terrestrial life, all stemming from this moment. The waters teem with possibility and potential, with the seeds of future glory planted in every innovation. Watch the tetrapods move through the murky Devonian waters, unaware of their own significance, simply trying to survive and reproduce. Yet their limbs are the beginning of something momentous, something that will transform the entire planet. Within these swimming fish beats the evolutionary potential for all land animals to come, including ourselves. In the shallow waters of the ancient world, a fish begins an experiment that will change everything. It tests its fins on land, discovering muscles where scales once sufficed. Imagine yourself as a gentle observer drifting through time itself, settling now in the late Devonian period, nearly 400 million years ago. The world is transforming around you. You watch as shallow estuaries and tidal flats create a peculiar opportunity, a meeting place between water and air where survival demands something extraordinary. The water levels fluctuate with seasonal rhythms. Pools become isolated. Oxygen grows scarce. In this challenging environment, a remarkable creature emerges from the murky depths, driven by hunger and necessity. This fish, called Tiktaalik in the language of modern scientists, is unlike anything that came before. As you observe it moving through the shallows, notice how its body seems suspended between two worlds. Its head is flattened like a crocodile, and its neck can move independently, a feature no fish before it possessed. Along its sides stretch fins that are neither quite the delicate appendages of swimming fish, nor the true limbs of land animals, but something beautifully in between. Feel the weight of evolutionary time pressing upon this creature. Within its pectoral fins, hidden beneath flesh and scale, lie bones arranged in a pattern that will become startlingly familiar. One central bone, then two, then a series of smaller bones branching outward. These are proto-fingers, proto-toes, the architectural blueprint for the arms and legs of every land animal that will ever exist. As this fish moves, these bones flex and bend with purpose. They are strong enough to push, to pull, to lever the body forward across wet rock and through shallow sediment. Watch now as Tiktaalik drags itself partially onto a muddy bank, its fins splaying beneath it with newfound purpose. This is not graceful movement. It is clumsy, experimental, almost desperate. But something profound is happening. The creature's body weight, once supported entirely by water's forgiving embrace, is now being borne partially by these modified fins. Muscles that evolved for gentle swimming motions are contracting with new intensity, developing new strength. The organism is teaching itself something its ancestors never knew: how to move through air instead of water. The gill slits still frame its head. Tiktaalik has not abandoned the water. It cannot breathe air the way land animals will eventually breathe it. But something precious is changing in its tissues. The lungs it uses to supplement its gills in stagnant water are growing more efficient, more prominent. This fish is not dying out of water. It is surviving, albeit briefly, in this alien medium. As your consciousness drifts through this crucial moment, consider what you are witnessing. Evolution is not a ladder with clear rungs. It is more like a river with many branches and confluences, with creatures exploring every possibility that survival allows. This fish, dragging itself across mud and stone, is not trying to become a tetrapod. It has no vision of the future. It is simply responding to immediate pressures, finding food in isolated pools, escaping predators in crowded waters, breathing where oxygen is scarce. Yet in its body, in the very structure of those experimental fins, the future is taking shape. The design that works for pulling a body across wet earth will persist. It will be refined through countless generations. Those proto-limbs will develop greater articulation. Digits will separate and specialize. Joints will become more complex. The skeleton will strengthen and reorganize to meet the demands of gravity in ways water never imposed. Other tetrapods will follow. Some will return to water entirely, their limbs becoming paddles once more in a different way. Others will venture further from the shore, into swamps and forests, adapting with desperate speed to this harsh new environment. But all of them will carry within their bones the memory of this moment, the ghost of a fin becoming a limb. With each movement on sand and stone, this creature is writing the history of all future land animals into its body. The land is being colonized, inch by inch, species by species, transforming from a wasteland of rock and soil into a living tapestry of green and growth. Imagine yourself standing in a landscape that would have seemed utterly alien to your ancestors just a few 100 million years ago. The continents stretch before you in their slow waltz across the planet's surface, and where once there was only bare stone and barren soil, life is now creeping outward with quiet determination. The air itself feels different here, thickening with moisture and the subtle sense of growing things. This is the Devonian world, and it is awakening. The pioneers of this terrestrial transformation are humble in appearance, but revolutionary in their impact. The plants that emerged from the water's edge have grown bold and ambitious. Where once they clung to shorelines in modest gatherings, they now venture deeper into the interior of continents. Ferns unfurl their delicate fronds in protected valleys, creating shelter where none existed before. Primitive trees, still simple by modern standards, push upward from the soil with remarkable persistence, their roots burrowing deeper into the earth with each season's growth. These wooden structures, sturdy and strong, create the first genuine shade on land, the first real refuge from the intense sun that beats down without mercy. As you move through this emerging landscape, you begin to notice the soil itself is changing. It is no longer merely rock and dust. It is becoming rich with life. Insects that never knew the water world are thriving here, their armor-like exoskeletons perfectly suited to the challenges of air and earth. Millipedes curl through the leaf litter, their many legs carrying them in patient search of decomposing matter. Spiders have arrived, delicate architects spinning their invisible traps between plant stems. Scorpions lurk beneath stones, their ancient design proving perfectly adapted to these new realms. The arthropods are diversifying with astonishing speed, filling every available niche, every possible role that the dry land offers. Beneath the surface, the earth itself teems with activity. Worms and primitive insects burrow and tunnel, aerating the soil, breaking down the first fallen leaves and dead plant material. Fungi spread their invisible networks through the ground, forming partnerships with plant roots that will sustain the green world for all time to come. These unseen collaborations are as important as the visible drama above ground, for without them, the plants cannot truly thrive. The partnership between root and fungus, between plant and soil organism, is becoming the foundation upon which entire ecosystems will be built. The amphibians that were gaining confidence in the previous age now move with greater freedom across this transformed landscape. These remarkable creatures, no longer entirely dependent on water, are exploring the possibilities of the open air. They climb upon rocks and logs, their limbs carrying them into places their aquatic ancestors could never have imagined. As they move between water and land, between element and element, they are writing their own evolutionary story into being. Each adaptation, each small improvement in their limbs and lungs and hearts represents a choice made by the living world to expand its reach, to claim new territory, to transform the planet's very surface. The transformation is gradual but unmistakable. Where there was silence, now there are sounds. Insects chirp and buzz. The rustling of leaves creates a constant whisper. The water's edge, once the boundary between two entirely separate worlds, is becoming a zone of mingling and exchange. Creatures move between realms with increasing ease. The barriers are dissolving, not in a dramatic moment, but in this patient, persistent colonization that is rewriting the rules of existence. You can sense the momentum building, the energy of a world discovering new possibilities. The continents are being transformed from lifeless monuments to geology, into active participants in the drama of existence. Life has discovered that it need not remain confined to the water. The land is calling, and life is answering with vigor and variety. A new world is being born on the surface of our planet, and it is as miraculous as the ocean's first stirrings of life. Once again, the oceans face a trial, as environmental changes stress the delicate balance of marine life. The world that seemed so alive with possibility during the Middle Devonian now enters a period of profound uncertainty. You drift backward through time, observing the slow and inexorable transformations that will reshape the seas and reshape the course of evolution itself. The waters that once teemed with armored fish, graceful predators, and countless invertebrates begin to experience profound stress. Oxygen levels fluctuate dramatically in the ocean depths. Vast dead zones expand where nothing can survive. Regions of complete anoxia spreading across the seafloor like shadows creeping across a landscape at dusk. The causes are complex and interwoven. Glaciation in the southern continents pulls water from the oceans, changing sea levels dramatically. Massive volcanic eruptions pump ash and gases into the atmosphere, blocking sunlight and cooling the climate. Ocean currents shift, disrupting nutrient distribution. The land, increasingly colonized by plants, begins to shed enormous quantities of sediment into the seas, clouding the waters and smothering the seafloor. The creatures that ruled the oceans only millennia before now find themselves struggling to adapt. The placoderms, those armored fish that seemed so perfectly designed for their world, begin to disappear. Species after species vanishes from the fossil record. The great predatory armored fish that once hunted with such efficiency fade into memory. Reef-building organisms collapse, their intricate structures toppling into silence. You witness the coral reefs, so vibrant and full of life, becoming barren wastelands of broken limestone and decaying matter. The trilobites, those ancient survivors who had endured for nearly 300 million years, suffered devastating losses. Many lineages simply ceased to exist. This is not a single cataclysmic moment, but rather a series of extinction pulses, waves of environmental stress washing over the biosphere. Some scientists will eventually call it the late Devonian extinction, though extinction hardly captures the prolonged agony of it all. The crisis unfolds over several million years, a slow strangulation rather than a sudden blow. Each pulse removes a portion of life's diversity, each one reshaping the remaining survivors' world in significant ways. Yet there are survivors. In the freshwater streams and rivers running from the newly elevated landmasses, the tetrapods continue their quiet revolution. These creatures that ventured onto land with their peculiar lobed fins adapted into limbs continue to diversify. They are not yet fully terrestrial, spending much of their lives in water, but they possess something precious: adaptability. The very features that allowed them to survive in oxygen-poor freshwater ponds serve them well when the oceans become increasingly hostile. Their lungs, their sturdy fins, their ability to move across wet ground, all these become advantages in a changing world. You watch as the fish that remain in the oceans undergo their own transformations. The jawed fish that survived the earlier extinctions continue to flourish in new forms. Sharks, those efficient predators, demonstrate remarkable resilience. Their flexible bodies and keen senses allow them to navigate the changing oceans. New niches open up as competitors disappear. Evolution works ceaselessly, driven by the desperation of survival and the opportunities presented by empty ecological spaces. The shallow seas, once overwhelmingly diverse, become simpler in structure. The Great Reef ecosystems will take millions of years to fully recover. The seafloor, once carpeted with life, becomes quieter. Yet this apparent decline contains the seeds of future renewal. With dominant species removed, new organisms will rise to prominence. The stage is being cleared for the next act of life's grand drama. This extinction teaches a difficult lesson about the fragility of balance and the power of environmental change. For all their success, for all their adaptations, life at any given moment is vulnerable to forces beyond prediction. The oceans that seemed so endlessly abundant have proven finite in their tolerance. The ecosystems that appeared so stable have fractured under stress. Yet once again, resilience carries life through, each extinction teaching new lessons about adaptation and survival. Imagine a world where the land is dominated by vast, humid swamps filled with plants of otherworldly proportions and insects as large as modern birds. You stand at the threshold of the Carboniferous period, approximately 300 million years ago, and the air itself feels different against your skin. It is thick, moisture-laden, heavy with the breath of countless organisms and the sweet decay of ancient growth. The oxygen content in the atmosphere has climbed higher than it will be for millions of years to come, reaching levels that seem almost intoxicating to your modern senses. This abundance of oxygen will transform life in ways that challenge everything you thought possible about the natural world. As you move deeper into these primordial landscapes, you begin to understand what has driven the resilience learned through previous extinctions. Life has seized this opportunity with remarkable vigor. The swamps stretch endlessly in every direction, a labyrinth of water and vegetation with no clear boundary between solid ground and liquid expanse. The plants tower above you in impossible formations. Vast club mosses reach heights that rival modern skyscrapers, their trunks perfectly straight and utterly alien in their appearance. Ferns of every conceivable size create an understory of verdant complexity, their fronds unfurling like the fingers of sleeping giants. Seed ferns and early conifers push upward, their forms still experimental, still evolving in this rich and humid world. The water itself seems alive with activity. Amphibians, those remarkable creatures that have mastered life both in water and on land, move through the shallows with surprising agility. Some have grown quite large, their bodies becoming increasingly specialized for particular ecological niches. You can hear their croaks and calls echoing through the swamp, a primitive chorus that speaks of territorial competition and reproductive urgency. The first true reptiles are beginning to appear, creatures that have finally severed their dependence on water for reproduction, their eggs sealed within protective shells that allow them to survive on dry land. But the most striking feature of these carboniferous swamps is not the plants or the early reptiles. Your attention is drawn upward, to the air itself, where the true rulers of this world make their presence known. The insects have undergone a transformation so dramatic that you must blink several times to convince yourself that your eyes are not deceiving you. Dragonflies with wingspans approaching a meter glide through the humid air with predatory grace. Their enormous compound eyes, capable of perceiving movements far too swift for human perception. These aerial hunters are far larger than any dragonfly that will ever exist in the future world, their size permitted and sustained by the exceptional oxygen levels that permeate the atmosphere. Other insects swarm through the vegetation in numbers that seem almost impossible to comprehend. Millipedes as thick as your leg undulate across the forest floor, their segmented bodies designed with mechanical efficiency for their endless consumption of decaying matter. Scorpions the size of small dogs emerge from crevices in the bark, their venomous tails curved in perpetual readiness. Cockroaches in bewildering variety scuttle through every available space, their adaptability allowing them to exploit virtually every ecological opportunity the swamps present. As you observe these creatures moving through their daily existence, you begin to grasp the profound significance of what you are witnessing. The plants surrounding you will eventually die and fall into the stagnant waters below. Their remains will accumulate in vast layers, compressed and transformed over millions of years into coal, those dark deposits of concentrated ancient sunlight that will one day power human civilization. But for now, in this moment, the plants exist simply as living tissue, photosynthesizing with remarkable efficiency in the oxygen-rich air, converting sunlight into the chemical energy that sustains this entire complex ecosystem. The carboniferous world is a world of excess and abundance, of life pushing every boundary, of evolution experimenting boldly with form and size. The humidity clings to you. The sounds of insects fill the air around you in an almost overwhelming chorus. And the sheer verdancy of the vegetation creates a sense of being utterly enveloped by life itself. In these primordial forests, the insects reign as masters, having evolved into forms of astonishing complexity and size. In the carboniferous swamps, amphibians thrive, but among them, a new kind of vertebrate is evolving, an innovation that will change the history of life. The air itself seems to shimmer with possibility as you drift through these ancient wetlands, observing the remarkable creatures that call this era home. Picture yourself standing at the edge of an enormous swamp, where the water stretches endlessly beneath a canopy so thick it filters the sunlight into a perpetual twilight. The amphibians here have become increasingly diverse and specialized. Some are slender and graceful, hunting insects with precision. Others are massive, powerful predators that dominate the shallow waters and muddy banks. The largest among them, the temnospondyls, are formidable creatures, some reaching lengths that rival modern crocodiles. Their descendants will eventually fade away, but for now, they are the undisputed rulers of this aquatic realm. You watch as an amphibian drags itself across the wet ground, its powerful limbs pushing its muscular body forward. It has just laid its eggs in the water, as amphibians must do. These eggs are soft, gelatinous spheres, vulnerable and dependent on moisture. The larvae that hatch will develop in the water before eventually transforming into air-breathing adults. It is a life cycle bound irrevocably to aquatic environments, a constraint that limits where these creatures can venture. But as you observe more carefully, you notice something extraordinary beginning to unfold. Among the amphibians, certain lineages are changing. These reptiles, as we will come to call them, are small at first, easily overlooked among the giants around them. Yet they possess something revolutionary. Their eggs are different, protected within a leathery shell, sealed with specialized membranes. These eggs contain everything an embryo needs to develop on land. No freestanding water is required. No larval stage in the water is necessary. Life can now complete itself entirely on dry ground. This innovation, the amniotic egg, represents one of the most profound breakthroughs in the entire history of life. As you contemplate it, sense the significance rippling forward through time. The egg itself becomes a contained world, a portable ocean where the developing creature floats in its own private sea. Membranes function like lungs, allowing gases to pass through while keeping the environment stable. Nutrients stored in the yolk sustain growth. Waste is carefully managed within protective structures. It is an engineering marvel born not from conscious design, but from countless generations of subtle improvements and refinements. Watch as these early reptiles begin to explore territories that had previously been impossible for vertebrates to colonize. They venture into drier regions, away from the perpetual dampness. They climb onto higher ground. They explore crevices and burrows that amphibians cannot access. Slowly, methodically, they radiate into new ecological niches. Some develop specialized scales that reduce water loss. Others adapt their metabolism to function more efficiently on land. The innovations build upon one another, each generation slightly better suited to terrestrial existence than the last. The amphibians do not disappear. Many will persist and diversify, adapting to specific ecological roles in the freshwater and coastal environments. But the reptiles represent a profound shift, a breaking of the final chains that bound vertebrates to water. From this moment forward, the colonization of land will accelerate. Deserts, grasslands, and forests will eventually fill with reptilian life in forms almost impossible to imagine from this vantage point in time. Feel the momentum building as you observe these small, unassuming creatures, recognizing them as ancestors of creatures yet to come. The dinosaurs that will dominate the next era are walking invisible paths through these ancient swamps, coded into the genes of these humble reptiles. The lineage that leads to modern snakes, lizards, and turtles is establishing itself. Even the lineage that will eventually produce birds, and much later, mammals, can be traced to these pioneering amniotes. The water continues to lap against the shore. The insects buzz overhead. The amphibians croak their evening songs. But underneath this familiar scene of carboniferous life, a transformation is underway. Slowly, invisibly, the balance of power is shifting. The age of amphibian dominance is beginning its gentle decline, not through catastrophe, but through the quiet triumph of adaptation. The amniotic egg is the key that finally allows vertebrates to unlock all the possibilities that dry land offers. The continents that have drifted separately through the ages now embark on their greatest journey, moving toward each other in a slow and inexorable dance. Picture yourself floating above the earth as a silent witness, watching the great landmasses creep across the ancient seas like enormous ships returning to harbor after untold millennia of wandering. This is the Permian period, a time of profound transformation when the scattered fragments of the world's crust gradually converge and fuse into something unprecedented. A single, unified supercontinent that will reshape everything life has come to know. For hundreds of millions of years, the continental plates have drifted independently, each carrying its own complement of creatures and plants toward distant destinations. But now, as if responding to some cosmic call, they begin their convergence. The southern supercontinent of Gondwana, a massive landmass that has sheltered countless unique species, edges northward. From the east comes Laurasia, another immense realm of mountains and valleys. Smaller continental fragments nestle into the gaps between them like puzzle pieces, finally finding their proper places. Bit by bit, over tens of millions of years, they press together, mountains rising where continents collide, the seafloor buckling and deforming under unimaginable pressure. As you observe this slow-motion catastrophe, imagine what it means for the oceans. The world's seas have retreated dramatically as the continents merge. The shallow coastal waters that once supported rich and diverse communities begin to disappear. The vast marine highways that once allowed ocean currents to distribute heat and nutrients across the globe are disrupted and redirected. The very circulatory system of the world's oceans undergoes a violent reorganization, and with it, the climate begins to shift in ways that will test every living thing. The supercontinent they form is called Pangaea, a name that means all Earth. It is a world unto itself, a single landmass so vast and unified that it seems to contain infinity. But this unity comes with a terrible price. In the interior of this enormous continent, far from any ocean's moderating influence, the climate becomes extreme. The sun beats down without mercy on endless deserts where rain rarely falls. Temperatures swing wildly between scorching days and bitter nights. Massive dust storms rage across the landscape, carrying sand across hundreds of miles. These inland deserts grow so vast and inhospitable that they rival anything that exists in the modern world, creating barriers that few creatures can cross. The species that have adapted to coastal conditions and moderate climates find themselves suddenly displaced and desperate. Animals that evolved to exploit the abundance of shallow seas watch as their habitats shrink and vanish. The rivers and deltas that once nurtured so much life become more seasonal, drying up for parts of the year. Forests that thrived in certain climates begin to wither as the continental interior becomes a furnace. Yet even as familiar habitats disappear, new opportunities emerge for those creatures and plants able to adapt to the harsh, challenging environment. The amniotic egg, that remarkable innovation that allowed vertebrates to reproduce away from water and colonize the drier lands, now proves invaluable. Animals bearing this adaptation can shelter their developing young within a protective membrane, requiring no connection to standing water. These creatures have an advantage as the world transforms around them, and you can see them gradually expanding their dominance across the landscape. They venture into the deserts, venture into the sparse forests of the interior, competing and evolving in response to each new pressure the environment presents. The interior of Pangaea becomes a proving ground where only the most resilient and ingeniously adapted species can flourish. Large reptiles emerge as dominant predators, their forms becoming increasingly specialized for life in harsh, dry conditions. Herbivores develop new ways to extract nutrition from tough plants that have themselves adapted to desert existence. Insects undergo their own elaborate radiations, filling niches both large and small. Yet this great consolidation of continents, this geographic unification, proves to be a double-edged sword. The vast interior deserts mean that the diversity of life, once spread across many distinct ecosystems, must now concentrate in the remaining habitable zones. The reduction of coastlines means the loss of the abundant edge habitats where life has always thrived most prolifically. The result is a world transformed, one vast continent where the diversity of life faces new and formidable challenges. The Permian lands are ruled by creatures called synapsids, some of which are developing remarkable features that hint at a warm-blooded metabolism. Imagine yourself standing in the heart of Pangaea, that immense supercontinent where all the world's landmasses have finally collided. The air is thick and warm, with a quality unlike anything you've known in your journey through time. The landscape stretches endlessly before you, a vast tapestry of desert, scrubland, and sparse forests. This is the world of the synapsids, and it is fundamentally different from the reptile-dominated realms that preceded it. The synapsids first emerged long ago, humble creatures in the shadows of mightier reptiles. But here, now, in this compressed and challenging world, they have risen to dominance. Their skulls tell a story of evolution, working in unexpected directions. Unlike the reptiles around them, these creatures possess a single opening behind their eye sockets, a feature that seems small, almost insignificant, yet it is revolutionary. This opening anchors powerful muscles for chewing, muscles that grow ever more efficient, ever more capable. Watch as a large therapsid moves through the scrubland, its body held higher than typical reptiles, its limbs positioned more directly beneath it rather than splayed to the sides. There is purpose in its gait, an efficiency that speaks to something changing deep within its physiology. This creature is a cynodont, and its teeth are not uniform like those of common reptiles. Instead, they are differentiated. Incisors, canines, and cheek teeth specialized for different tasks. The precision with which it bites, the force it can generate, all of this suggests an animal with metabolic demands higher than its ancestors. As you observe these creatures more closely, you notice something even more remarkable. Their skeletons show evidence of bone structure that suggests rapid growth. The very tissue of their bones whispers of active, energetic lives. Some scientists of your own distant time would suggest that many therapsids were not cold-blooded at all, but warm-blooded, creatures that generated their own heat internally, maintaining constant body temperatures regardless of their surroundings. It is a hypothesis born from evidence written in bone and form. The advantages of such a metabolism are profound. A warm-blooded animal can remain active in cooler parts of the day, when reptiles lie sluggish. It can pursue prey with greater endurance. It can hunt through the night, when cold-blooded competitors slumber. The therapsids are embracing these advantages, growing larger, more diverse, more successful with each generation that passes. There is a particular grace to these creatures. Some are massive, apex predators with powerful jaws and formidable teeth. Others are smaller, swifter, more delicately built. The Permian therapsids include the Gorgonopsians, fierce hunters, with saber-like canines that pierce the air as they move. You watch one such predator stalking through a fern-bordered stream bed, its body tense with purpose, its eyes focused on prey only it can see. This is no mindless reptile, following blind instinct. There is intention here, strategy, intelligence manifesting in the Permian heat. But change is coming to Pangaea, though you cannot yet perceive it. The vast continent continues to shift and compress. Deserts expand and contract. The climate grows more extreme with each passing age. Life adapts and responds, always seeking equilibrium in a world that refuses to grant it. The synapsids continue to evolve, to refine their advantage. Their jaws grow more sophisticated. Their bones become ever denser, suggesting higher metabolic rates. Hair, that most important of mammalian features, may already be beginning to emerge in some lineages, though you cannot see it with certainty in this ancient dusk. These modifications seem minor in their own time, merely adjustments to an already successful body plan. Yet they represent something far greater, the very first steps on a path that will eventually lead to fur and whiskers, to nurturing young with milk, to consciousness itself. The therapsids rule this ancient world with confidence, their dominance seemingly assured. They cannot foresee the catastrophe that awaits at the end of the Permian, nor could they comprehend the strange new forms their descendants would eventually take. In these creatures rests the evolutionary potential for all mammals, including humans, though they know it not. At the boundary between two eras, life faces its greatest trial, an extinction event so severe that it nearly writes the final chapter of Earth's biological story. 252 million years ago, as the Permian period draws to its close, the world enters a time of unimaginable suffering and loss. The comfortable epoch that has sustained countless species for nearly 50 million years is about to shatter into oblivion. Picture yourself standing at the edge of a vast Permian ocean, watching the horizon with growing dread. The water, which has cradled an extraordinary abundance of life, begins to change. Around you, the ancient trilobites that have survived previous catastrophes swim in confused patterns. The great armored fish patrol the depths with increasing agitation. Something is terribly wrong, though none of them can comprehend the cascade of horrors about to unfold. The extinction does not announce itself with a single catastrophic moment, but rather as a mounting crescendo of planetary trauma. Vast volcanic eruptions erupt across what will one day be called Siberia, releasing torrents of lava that spread across an area larger than Western Europe. For perhaps 1 million years, the volcanic activity continues relentlessly, filling the atmosphere with ash so thick that sunlight becomes a memory. The darkness deepens and persists, and temperatures plummet as the ash blocks the sun's warming rays. But the volcanic horror brings more than mere darkness. Sulfurous gases pour into the sky, creating acid rain that falls across the oceans and lands alike. The chemistry of the seawater itself begins to transform. Oxygen depletes from the vast oceans that once teemed with countless species, creating vast dead zones where nothing can survive. Creatures that have adapted to oxygenated waters suddenly find themselves gasping in poisoned seas. They thrash and struggle against the chemical transformation of their world. On the continents, the temperature chaos creates a world of extremes. In some regions, searing heat arrives with brutal intensity. In others, the volcanic winter brings cold so severe that ancient forests collapse and wither. The land animals that survived countless previous challenges now face an environment that seems actively hostile to all life. The great sail-backed reptiles called dimetrodons, magnificent predators that have dominated terrestrial ecosystems, find their prey vanishing. The herbivores that fed them disappear first, their food sources obliterated by ecological collapse. The synapsids, those mammal-like reptiles that carry within their bloodlines the ancestors of all future mammals, experience unrelenting pressure. Most lineages simply vanish, their evolutionary potential extinguished before it can fully bloom. Only the smallest survive, huddled in whatever shelter they can find, consuming whatever scraps of life remain available. These survivors are not the mighty predators, but rather the humble, the small, the adaptable. Among them rest the ancestors of all mammals, including the species that will one day ponder its own origins and wonder at the depth of geological time. In the oceans, the devastation is even more complete and terrible. 96% of marine species are erased from existence. The ammonites, those beautiful spiral-shelled creatures that have been so successful throughout the Paleozoic era, are nearly annihilated. The reef ecosystems that have built magnificent underwater structures over millions of years are completely destroyed. Entire orders of organisms simply cease to exist, their evolutionary lineages cut short after tens of millions of years of development and adaptation. As you witness this unfolding catastrophe, you understand that you are observing the closest Earth has ever come to sterilizing itself of all complex life. The planet seems intent on erasing the biological achievements of hundreds of millions of years. The margin between continued evolution and total extinction becomes impossibly thin. Had the volcanic activity continued just a fraction longer, had the oxygen depletion become more severe, had the temperature swings grown even more extreme, Earth might have returned to the sterile, lifeless sphere it once was. Yet even in this nadir of suffering and loss, life persists in the most improbable ways. The survivors seem almost accidental, their continuation a matter of impossible chance. The world becomes a purgatory of diminished abundance, where the living struggle against overwhelming odds. The Great Dying is a moment when life's persistence itself is questioned, when survival seems less likely than oblivion. In the barren aftermath of the Great Dying, life faces a world emptied of most of its creatures. Yet somehow, survivors begin to spread and diversify anew. Imagine yourself floating gently above the scarred landscape of ancient Earth, where the scorched continents slowly begin to breathe again. The atmosphere, though still harsh and alien by modern standards, gradually stabilizes. The volcanic dust settles. The oceans, once choked with sulfuric compounds and depleted of oxygen, begin their slow transformation toward breathability. You drift across what would one day be known as Pangaea, that singular supercontinent where all landmasses have crashed together into one massive whole. The terrain before you is mostly barren rock and volcanic ash, punctuated by isolated patches of struggling vegetation. Where forests once dominated, now only scattered seed ferns and early conifers attempt to reclaim their territory. It is a humbling landscape, one that speaks to both devastation and possibility. In the shallow seas that surround this vast continent, microscopic life forms begin their patient work of rebuilding. These tiny architects of recovery are invisible to your eyes, yet they are essential. Bacterial mats proliferate across the seafloor, slowly restoring chemical balance to the oceans. Shelled creatures that survived the extinction begin to reproduce, their calcified bodies accumulating to form new limestone deposits. Each generation is larger than the last, a slow crescendo of biological determination. You witness the crucial moment when life begins to refill the empty niches. The small synapsids that survived the catastrophe emerge from their burrows more frequently now. These mammal-like creatures, modest and unremarkable by later standards, represent hope in this recovering world. They have inherited an Earth stripped of competitors, and they cautiously expand their territories. Some grow larger, others develop specialized teeth and jaws better suited to new food sources. Adaptability becomes their greatest strength. In the rivers and freshwater lakes, early reptiles begin to flourish once more. Small archosaurs, distant cousins of the creatures that would eventually dominate the Jurassic world, start to claim their places in aquatic ecosystems. They are not yet the dominant force they will become, but they are gaining ground, multiplying in the warm waters, diversifying into different forms and sizes. Some develop longer limbs for better pursuit of fish. Others grow more robust, capable of crushing harder prey. The recovery is neither swift nor complete. Millions of years must pass before diversity approaches anything resembling what existed before the extinction. Where once there were hundreds of species in a single genus, now there are only a handful. Entire families of creatures remain extinct, their ecological roles unfilled and waiting. The world is less vibrant, less saturated with life, but it is alive, and that is what matters most. You observe the gradual resurrection of forests. First, the seed ferns and conifers continue their tentative spread. Then, slowly, the cycads begin to flourish. These sturdy plants, with their impressive fronds and slow-growing trunks, become increasingly common. They provide shelter and food for the recovering animals. Insects, too, begin to diversify again, those hardy arthropods having survived in sufficient numbers to repopulate the emerging ecosystems. Beetles and dragonflies return to the skies and waters, filling ecological roles that have been absent for eons. The climate stabilizes further as the millennia pass. The intense volcanic activity gradually diminishes. Carbon dioxide levels in the atmosphere slowly normalize. Ocean circulation patterns reestablish themselves. These changes are imperceptible to human timescales, yet they are the foundation upon which the Triassic world is being rebuilt. As you survey this slowly transforming landscape, you sense something profoundly moving in this recovery. Life, having nearly been extinguished entirely, is reasserting itself with quiet determination. There is no drama in this process, no sudden explosions of diversity. Instead, there is something more profound. The simple, steadfast persistence of living things continuing to live, adapt, and spread despite nearly insurmountable odds. The Triassic recovery demonstrates a fundamental truth about existence itself. In this ancient world, slowly healing from its wounds, we witness the remarkable resilience embedded within life's deepest nature. Recovery from near extinction is a lesson in life's stubborn refusal to surrender to catastrophe. From the recovering world of the Triassic emerge creatures that will come to dominate the land for the next 165 million years. The dinosaurs. Imagine yourself standing in a vast, warm landscape where the continents have begun their slow dance apart. The air is thick and dry, carrying the scent of ancient conifers and primitive cycads. The world is still healing from the devastation of the Permian extinction, and into this recovering realm steps a small creature no larger than a chicken. This is Aeoraptor, a sleek bipedal hunter with sharp teeth and an alert gaze. It moves with a grace that speaks of something new, something different emerging from the ancient reptilian lineages. The dinosaurs do not arrive as the titans of legend. They come humbly, modestly, as modest participants in an ecosystem still dominated by other reptiles. Synapsids and dissonodonts still roam these warm continents, and the skies belong to flying reptiles called pterosaurs. The dinosaurs are merely another branch on the great tree of reptilian diversity, one among many. Yet within them burns something unique, something that will eventually transform them into the undisputed rulers of the terrestrial world. Feel the passage of those early Triassic millennia. Eons drift by like sand through an hourglass as these creatures gradually, almost imperceptibly, begin to change. Generation after generation, small variations accumulate. Some dinosaurs grow larger, others develop stronger hind legs. Still others discover new ways to hunt or find food. The diversity expands slowly, like ripples spreading across still water. Picture the Middle Triassic now. The world grows warmer still, and the dinosaurs diversify. Plateosaurus emerges, a creature perhaps 10 meters long, wandering on two hind legs through great forests. It is a herbivore, stripping leaves from the high branches that other creatures cannot reach. Its longer neck and body size represent an evolutionary experiment in accessing new food sources. Around it move smaller cousins, bipedal hunters with names that echo through deep time. Coelophysis, a creature of elegance and speed, barely 2 meters long but perfectly designed for pursuing swift prey. These early dinosaurs possess an elegant efficiency in their design. Their legs are positioned directly beneath their bodies, unlike the sprawling limbs of lizards and other reptiles. This gives them greater agility, a more efficient gait, the ability to move with purpose across the warming landscape. Many of them run on two powerful hind legs, with their tails stretched behind them for balance, creating a posture that is recognizably different from anything that has come before. Drift forward through the remainder of the Triassic period. Millions of years accumulate. The dinosaurs continue their slow ascendancy. They do not yet dominate, but they are becoming more common, more diverse, more successful. Other reptiles still thrive alongside them. The great synapsids have diminished, but survivors remain. The world is a tapestry of reptilian forms, each filling its particular niche, each adapted to its particular way of life. But notice, as you observe this ancient world, that the dinosaurs possess something special. Perhaps it is their superior mobility. Perhaps it is their efficient metabolism. Perhaps it is simply the fortune of being in the right place with the right adaptations as conditions slowly shift. Whatever the reason, they are becoming increasingly significant parts of their ecosystems. Where once they were curiosities, they are now regular inhabitants. Where once a human observer would have struggled to identify them among the bewildering diversity, they now comprise a notable percentage of the terrestrial vertebrate fauna. The late Triassic world grows even warmer. Vast deserts spread across the supercontinents. The climate becomes more seasonal, with distinct dry and wet periods. The dinosaurs, with their efficient locomotion and adaptability, prove particularly suited to these conditions. They exploit new niches, develop new forms, multiply in number and variety. The stage is being set for a transformation that will take place in the periods to come. As the Triassic draws toward its conclusion, notice the trajectory. The dinosaurs have moved from obscurity to prominence. They have diversified from a single common ancestor into dozens of distinct forms. They have developed different sizes, different diets, different hunting strategies. The potential is clearly visible, even if the apex of their dominance still lies far in the future. Though small and modest at first, these creatures carry within them the potential to become the most dominant land animals in Earth's history. The world transforms into a kingdom of reptiles, where creatures of stunning size and power walk the earth, swim the seas, and soar through the skies. You drift backward through time, watching as the continents continue their slow dance across the globe. The supercontinent Pangaea has broken apart further now, creating new oceans and seaways that allow life to flourish in previously isolated regions. The climate has warmed considerably, with lush vegetation spreading across the land in verdant waves. There are no ice caps at the poles, and the air itself seems rich with moisture and possibility. Here, in this Jurassic world, the modest creatures you witnessed before have inherited the Earth completely. The dinosaurs have undergone a remarkable transformation, diversifying into countless forms of extraordinary size and specialization. You watch in wonder as a Brachiosaurus moves slowly through a prehistoric forest, its neck stretched impossibly high toward the canopy above. This creature, longer than 3 buses placed end to end, weighs nearly as much as 100 elephants, yet it moves with a gentle grace that belies its colossal mass. Its heart, you might imagine, is itself as large as a small car, pumping blood through chambers that can barely comprehend their own vastness. Around this gentle giant, smaller sauropods browse and move through the landscape. Some are more compact, though still towering above the smaller creatures scurrying beneath their feet. The sauropods have become the dominant herbivores, their long necks allowing them to reach vegetation that no other creature can access. They are the gentle giants of this age, traveling in herds across plains and through forests, their presence reshaping the very landscape they traverse. But the Jurassic is not solely a world of peaceful plant eaters. You turn your attention to the shadows beneath the trees, where a different kind of majesty emerges. Here prowls Allosaurus, a predator of devastating efficiency. Smaller than the giants of later ages, it is nonetheless a perfect hunter, moving with calculated intelligence. Its 3-fingered claws curl with lethal precision, and its teeth are designed to tear and rend with surgical accuracy. Allosaurs hunt in coordinated groups, demonstrating social structures and cooperative strategies that hint at genuine intelligence. They pursue their prey across sun-dappled clearings, their bodies lean and muscular, built for speed and power in equal measure. The world above the land belongs to another dynasty of reptiles. Pterosaurs drift through the skies with wings of stretched membrane and hollow bones, soaring on thermals that rise from the warming earth. Some are small, delicate creatures no larger than a sparrow. Others, like Pterodactylus, achieve sizes that rival modern eagles. These creatures are not dinosaurs, though they share the world with them, and they rule the air with an elegance that has never been matched. Their wings extend and catch the wind, and they wheel and turn with a grace that seems almost supernatural. The oceans, too, have become domains of reptilian power. Ichthyosaurs, looking remarkably like dolphins, slice through the warm waters with incredible speed. Plesiosaurs, with their long necks and flippers, move through the depths in search of prey. Mosasaurs, the true ocean predators, patrol the seaways with the same deadly efficiency that their cousins display on land. The seas are alive with possibility, teeming with life in forms that seem utterly alien to your modern sensibilities. As you observe this world of dinosaurs in their fullest glory, you sense something profound. This is their moment, their golden age. The small mammals that scurry in the shadows, and the few early birds that flutter uncertainly through the branches are insignificant, easily overlooked. The reptiles have achieved perfect dominion. Their diversity is staggering, their size unprecedented, their dominance absolute. They have adapted to every ecological niche, filled every role, conquered every environment. The sun sets golden across ancient horizons, and you watch as creatures settle into rest. There is a rightness to this world, a sense that it has found its perfect form. The reptiles seem invincible, their rule eternal. The Jurassic is an age of reptilian majesty, a golden era that seems destined to last forever. The sky itself is conquered by two remarkable groups: the pterosaurs with their leathery wings, and the early birds with their revolutionary feathers. Imagine yourself standing in a vast, sun-drenched landscape of the Jurassic period, gazing upward into an impossibly blue sky. The air itself seems alive with movement, filled with creatures that have achieved what few vertebrates before them dared to attempt. The very atmosphere becomes their domain, their realm of possibility. Picture the pterosaurs first, magnificent beings that emerged millions of years before birds took to the air. These are not dinosaurs, though they share the Mesozoic world with their cousins on the ground. Watch as a pterodactyl glides overhead, its membranous wings stretched between elongated finger bones, and its body, translucent skin catching the golden light of a Jurassic afternoon. These wings are unlike anything that came before them, constructed from a framework of bone and supported by a thin layer of muscle and skin. The pterosaurs are marvels of engineering, some growing to the size of modern aircraft, their hollow bones making them light enough to soar on thermal currents rising from sun-baked Earth. But there is another revolution happening simultaneously, quieter perhaps, yet destined to change the world forever. Small theropod dinosaurs, diminutive cousins of the great carnivores that roam below, are experimenting with something extraordinary. Their feathers, once possibly useful only for warmth and display, are becoming something more. Feel the transformation as you witness Archaeopteryx, that miraculous bridge between earth and sky, a creature that is neither quite dinosaur nor quite bird, but something magnificently between. These early birds possess hollow bones, powerful legs, and increasingly sophisticated wing structures. Their feathers are not the crude coverings of their ancestors, but precise instruments designed for air currents and lift. Watch as one launches itself from a perch, flapping with purposeful intent, not yet soaring but rather bounding through the air, each beat of its wings carrying it further, higher, more deliberately into the realm above. The differences between these two flying groups are profound and beautiful. The pterosaurs, with their membranous wings, are supremely adapted for soaring and gliding, efficient masters of the upper atmosphere. They are likely relatively quiet flyers, relying on thermals and wind currents to carry them across vast distances. The early birds, meanwhile, are developing the capacity for powered flight, the ability to generate lift and thrust through muscular exertion, to climb into the sky through their own strength rather than fortune of the wind. As you watch across millions of years, something remarkable becomes apparent. The pterosaurs seem perfectly suited to their world, their design elegant and effective. Yet there is something about the bird's approach that suggests greater potential, greater adaptability. Their feathers can be adjusted with minute precision. Their powerful legs and evolving skeletal structure allow for greater maneuverability. They are learning to think in 3 dimensions, to use the sky not merely as a place to drift, but as a space to hunt, to escape, to explore. The Jurassic sky is a realm of wonder, shared between these 2 experiments in flight. Pterosaurs command the large spaces, their pteroid membranes catching up drafts over oceans and mountains. Birds dart and weave through forests and across grasslands, their agility increasing with each passing generation. Both groups have conquered gravity. Both have freed themselves from the constraints that bound their earthbound cousins. This is one of evolution's most transcendent moments, the moment when vertebrate life first seized the realm of air itself. It is an achievement that speaks to the incredible creativity of natural selection, the way constraints can birth innovation, how competition drives organisms toward previously unimaginable solutions. The sky, once empty of large vertebrate life, now thrums with the beating of wings, the calls of creatures experiencing freedom in dimensions their ancestors could never have conceived. Flight is a gift evolution grants to the bold, allowing life to explore dimensions previously forbidden to vertebrates. While dinosaurs command the world's grand stages, small mammals, descendants of the therapsids, live quietly in the shadows, waiting for their turn. For over 100 million years, they have persisted in the undergrowth, in burrows beneath the soil, in the hollow spaces of ancient trees. These creatures are modest in appearance, often no larger than a modern mouse or shrew. Yet they carry within their tiny frames the blueprint of an extraordinary future. Picture yourself moving through a Mesozoic forest at dusk, when the great dinosaurs have settled for the night and the temperature begins its gradual decline. This is the time when the mammals emerge. You might catch glimpses of them in the fading light, small, furry shadows moving with remarkable purpose through the leaf litter and fallen branches. Their eyes are large and alert, adapted for the darkness. Their ears twitch at every sound, detecting vibrations far too subtle for the enormous reptiles that dominate the daytime world. They are creatures of the margins, existing in the spaces between dominance and obscurity. These early mammals are endothermic, meaning they generate their own body heat from within. This seemingly modest adaptation is profound in its implications. While dinosaurs must bask in the sun to warm their muscles and minds, mammals maintain their internal furnace regardless of external conditions. They can be active when the world is cool. They can hunt when others sleep. They can maintain the high metabolic rates necessary for quick movement and intelligent behavior, even in the depths of night. The mammals of this era have developed hair to insulate their bodies, another revolutionary adaptation. This simple covering is transformative, allowing them to retain precious warmth and survive in conditions where cold-blooded creatures cannot. Some have begun to secrete milk to nourish their young, a development that will eventually reshape the bond between parent and offspring. These animals invest in their children in ways that reptiles do not, protecting them, teaching them, ensuring their survival through knowledge passed from generation to generation. What is remarkable about these small mammals is their restraint. They do not compete directly with dinosaurs. Instead, they have carved out ecological niches that the great reptiles have largely ignored. Some hunt insects in the darkness. Others feast on seeds and nuts, playing a crucial role in seed dispersal and forest regeneration. Some hunt small lizards and amphibians. A few have even begun to develop specialized teeth for processing different foods, evidence of a versatility that will serve their kind well in ages to come. Their brains, proportionally larger than those of reptiles, buzz with possibility. They have developed complex social behaviors. Some live in loose family groups. Others establish territories and communicate with one another through vocalizations and scent marking. They solve problems. They remember. They adapt their behavior based on experience. These abilities seem unremarkable now, overshadowed by the drama of massive predators and armored herbivores. Yet they represent a different kind of evolutionary strategy, one based not on raw size and power, but on intelligence, flexibility, and emotional bonds. As you watch these creatures move through their nocturnal world, you sense their patience. There is no urgency in their movements, no desperation. They do not rage against their smallness or mourn their lack of dominance. They simply live, adapt, and persist. Night after night, generation after generation, they continue their quiet existence, filling their ecological roles with steady competence. The dinosaurs will not reign forever, though no mammal in this Mesozoic world could possibly imagine a time without them. The great reptiles have held dominion for so long that their supremacy seems as permanent as the earth itself. Yet the modest mammals continue their work, generation succeeding generation, their genes slowly accumulating advantageous changes. They refine their senses, their reproductive strategies, their social behaviors. They develop new teeth for new foods. They expand into new habitats. They wait, not with conscious anticipation, but with the patient persistence of life itself. Patience and adaptation are their strengths, and though they do not yet know it, the future belongs to them. The Cretaceous period brings a transformation to the plant world, the emergence of flowers that will eventually paint the world in colors. Imagine yourself floating above the continents of this ancient time, watching as the planet slowly shifts and changes. The age of dinosaurs continues, but something remarkable is happening in gardens and forests across every landmass. Flowering plants are beginning to spread, starting modestly and then with increasing confidence, as if nature itself is preparing to paint with a palette that has never been used before. For over 100 million years, the world has belonged to ferns and conifers, cycads and ginkgos. These plants have served the dinosaurs well, providing endless food and shelter. But now, deep in the hearts of ancient forests, something new is stirring. Flowers begin to bloom, simple at first, almost shy in their appearance, but gradually becoming more elaborate and colorful. With them comes a crucial partnership that will reshape life itself. Insects discover these flowers, and flowers discover insects. Bees, beetles, butterflies, and countless other creatures begin to pollinate, creating a dance of interdependence that will eventually transform every ecosystem on Earth. Watch as these flowers spread slowly across the Cretaceous world. In what will one day be North America, delicate magnolias unfurl their petals. In ancient Asia, the first water lilies float upon peaceful lakes. Along the coasts of what will become Europe, flowering shrubs push through the undergrowth. This is not a sudden explosion, but a gradual awakening, like dawn spreading across the sky. The flowering plants move cautiously, testing new environments, finding their places in the great tapestry of life. They adapt to deserts and wetlands, to highlands and lowlands, discovering that their flowers can attract pollinators in ways that ancient plants never could. But the dinosaurs themselves do not simply fade into the background during this flowering. They continue to evolve in remarkable ways. The skies above fill with pterosaurs, those magnificent flying reptiles with wingspans that stretch like the shadows of clouds. Below them, smaller dinosaurs dart through the forest understory, feathered bodies catching the sunlight. Some are no larger than chickens, others the size of bears. They chirp and click and call to one another, creating a symphony of prehistoric life. And dominating it all, at the very peak of this era, comes the ultimate predator. Tyrannosaurus rex emerges in the later Cretaceous, and it is a creature of terrible magnificence. Imagine standing in a forest clearing as this massive form approaches. Its body stretches nearly 40 feet long, its head enormous and terrifying, filled with teeth like daggers made of bone and enamel. Its tiny arms, seemingly insignificant, nevertheless contain muscles capable of tremendous strength. But what makes Tyrannosaurus truly remarkable is not merely its size, but its sophistication. This is a refined predator. Millions of years of carnivorous evolution distilled into one apex being. It hunts with intelligence, moving through the landscape with a grace surprising for something so large. It is the culmination of dinosaurian adaptation, the ultimate expression of what these creatures could become. Around the great tyrannosaurs roam herds of horned dinosaurs like Triceratops, their magnificent frills raised in displays of dominance and beauty. Ankylosaurs, armored like tanks, lumber through the undergrowth. Long-necked sauropods, the last of their kind, still reach toward the canopy to feed on the highest leaves. The Cretaceous world is one of remarkable diversity, where every ecological niche is filled by some form of dinosaur, from the smallest insectivore to the mightiest carnivore. This is a world in transition, though none of its inhabitants could possibly know it. The flowers continue their quiet revolution, spreading and diversifying. The dinosaurs continue their dominance, refining their forms and behaviors. Both lineages are reaching their peaks, achieving levels of complexity and specialization that previous eras never witnessed. The climate shifts gradually, the continents continue their slow waltz across the globe, and life adapts with endless creativity and persistence. In this world of flowers and great reptiles, evolution reaches new heights of complexity and beauty. In the final chapters of the dinosaur's story, a creature emerges that represents the absolute peak of reptilian predatory evolution, Tyrannosaurus rex. Imagine yourself walking through the warm, humid landscapes of what will one day be called North America. Some 68 million years ago, the air hangs thick and heavy around you, carrying the scent of coniferous forests and the rich, fertile smell of ancient soil. Ferns and cycads stretch across the ground, their fronds moving gently in a breeze that has traveled across this vast continent, untouched by human footprint. The forest falls silent. Every creature within miles senses it before seeing it. A vibration travels through the earth, rhythmic and purposeful, each footfall a tremor that echoes through bone and sinew. The great trees seem to lean away as if by instinct, parting for something that demands passage. Then it appears through the vegetation, and your breath catches. Tyrannosaurus rex rises before you like a moving mountain of muscle and purpose, 40 feet long from the tip of its powerful tail to its enormous skull, weighing as much as an elephant. This creature embodies perfection, refined through millions of years of relentless natural selection. Its skin gleams in the dappled sunlight, dark and textured, bearing the scars of countless battles and hunts. Those scars tell stories of a life lived at the absolute apex of existence. The dinosaur's head is a marvel of evolutionary engineering. That famous bite, the jaw that could crush bone with a force exceeding 12,000 pounds per square inch, opens and closes with the ease of long practice. Teeth like curved daggers line those massive jaws, each one designed with surgical precision to puncture, tear, and rend. The sense of smell, housed in nasal passages that take up a considerable portion of its skull, far exceeds that of any modern creature. Tyrannosaurus rex hunts not merely with eyes and teeth, but with an olfactory sense so acute it can detect the blood of prey from miles away. Yet this is no mindless brute. Watch how it moves through the forest. There is intelligence in the way it calculates each step, placing its weight with the precision of a skilled hunter. The arms, small and seemingly insignificant, contain claws that can rip through flesh as easily as water. Its bipedal stance gives it speed and maneuverability that belies its enormous size. When it runs, it can reach speeds approaching 30 miles per hour, a velocity no prey of the late Cretaceous can maintain indefinitely. The eyes of Tyrannosaurus rex are positioned forward on its skull, allowing for binocular vision and depth perception superior to most other dinosaurs. It can judge distances with remarkable accuracy, a necessity for a predator that hunts creatures nearly as large as itself. Triceratops, with their horns and bony frills, test the limits of even this magnificent hunter's abilities. The massive sauropods are beyond reach, but the varied herbivores that roam these lands live in constant awareness of that distinctive silhouette against the horizon. Watch how the great rex pauses at the edge of a clearing where a herd of hadrosaurs feeds on the vegetation. Its nostrils flare, processing the air, reading the wind for information invisible to lesser creatures. The muscles along its powerful hind legs coil like springs. This moment, this choice between hunt and rest, is calculated through a brain that, while smaller in proportion to its body than modern predators, possesses genuine complexity. There is deliberation here, strategy, perhaps even something resembling emotion. The afternoon light shifts across its scales, revealing the subtle textures of a creature that has evolved over hundreds of millions of years specifically for this role. Every aspect of its being, from the leverage provided by its massive tail to the power in its rear legs to the cutting efficiency of its teeth, represents the accumulated wisdom of deep time, written in flesh and bone. Tyrannosaurs have ruled these lands for approximately 2 million years, and in this moment, as this individual hunts through forests that will one day be called Hell Creek, it cannot know that its line is entering its final chapter. 85,000 sunrises and sunsets remain to this species. This magnificent beast knows nothing of its impending doom, yet it lives every moment to the fullest, a creature of supreme power in its world. From the depths of space, a rock the size of a mountain races toward Earth on a collision course that will change everything. For millions of years, the dinosaurs have ruled the planet unchallenged, evolving into forms of breathtaking diversity and power. They have become comfortable in their dominance, spreading across continents, filling every ecological niche, adapting to jungles and plains and deserts. But their reign is about to end, and they do not see it coming. The asteroid hurtles through the void, a chunk of ancient stone and metal that has been drifting through space since the formation of the solar system itself. It has witnessed the birth of worlds, the death of stars, the turning of countless ages. Now it falls toward the blue planet, and nothing can stop it. The dinosaurs go about their lives in those final moments before impact. A titanosaur grazes in a forest clearing, its neck stretched impossibly high to reach the tender leaves of towering conifers. A pack of raptors hunts through dense undergrowth, communicating with clicks and calls, their minds sharp and their bodies lithe with predatory grace. A massive ceratopsian herd migrates across an ancient plain, creating dust clouds that rise into the amber sky. In the oceans, plesiosaurs glide through warm waters, and flying pterosaurs wheel through the air on wings that seem almost impossibly thin and delicate. These creatures embody the pinnacle of reptilian evolution, the very definition of success in their world. Then comes the moment. The asteroid strikes the Yucatan Peninsula with a force beyond comprehension. The impact releases energy equivalent to billions of nuclear weapons, exploding simultaneously. The ground beneath the collision point does not merely shake, it liquefies. Bedrock vaporizes in an instant, turning to superheated gas and plasma that explodes outward in a massive fireball. The energy is so tremendous that it carves a crater over 100 miles across, punching through the Earth's crust as if it were paper. The devastation radiates outward in concentric waves of destruction. Earthquakes of unimaginable magnitude rock the planet, registering at scales that would not be invented for millions of years. Mountains crumble, valleys collapse, the ground rolls in waves that topple trees and swallow creatures whole. Every living thing within 1,000 miles feels the ground convulse beneath them. But the local destruction is only the beginning. The impact throws countless tons of rock, dust, and ash into the atmosphere. This material spreads across the sky in ever-widening circles, rising higher and higher until it obscures the sun. Within hours, the dust blankets the entire planet. Daylight becomes as dim as twilight. Within days, perpetual darkness covers the earth. The temperature plummets. Photosynthesis ceases. As plants are starved of sunlight, the plants wither and die. The herbivores that depended on them begin to starve. The predators that hunted the herbivores soon follow them into extinction. The food chains collapse like dominoes toppling across a table, each fall triggering another. The dinosaurs, those mighty creatures that have dominated the planet for 170 million years, find themselves utterly unprepared for this catastrophe. Their massive bodies require tremendous amounts of food, and there is no food to be found. The cold penetrates their reptilian systems. They are adapted for a warm world, and the temperature has become brutally inhospitable. The darkness persists for months. The dust settles in layers, in some places many inches thick. Ash falls like dark snow, covering every surface with a fine gray powder. The sun, when it finally begins to be visible again, is a pale ghost in the sky. The radiation has increased, as the dust allowed ultraviolet rays to penetrate the atmosphere unfiltered. The forests that remain are charred and broken. The oceans are murky with suspended particles and choked with organic matter. In the skies, the last pterosaurs fail to find food and fall to earth. In the oceans, the last plesiosaurs surface for air that comes with increasing difficulty. In the forests and plains, the last dinosaurs collapse from hunger and cold. The creatures that dominated Earth for 170 million years simply cannot adapt quickly enough to survive what comes next. In a moment that lasts only seconds, the age of reptiles comes to a sudden and violent end. The impact throws countless tons of rock and dust into the atmosphere, creating a darkness more complete than any night the world has ever known. Where moments before the sun hung in the sky, casting golden light across the continents, now there is only shadow. The dust spreads rapidly, carried by winds that grow fiercer by the hour, racing across oceans and over mountains, blocking out the light that has nourished life for billions of years. Below this suffocating veil of ash and debris, the world grows cold. The sun's warmth cannot penetrate the thick curtains suspended in the air. Temperatures plummet day after day, hour after hour. Within weeks, the average global temperature drops by tens of degrees. In some places, the cold becomes so severe that it seems winter itself has become eternal, as though the warmth of the sun is only a memory, a story told by creatures who lived in a previous age. The plants are the first to feel this cruel transformation. Without sunlight, photosynthesis ceases. The vast forests that covered the continents cannot survive in this perpetual darkness. Trees that have stood for centuries begin to wither. Flowering plants that bloomed in response to the sun's rays fade and die. Within months, what were once lush landscapes turn to brown and gray. The oxygen content in the atmosphere begins to fluctuate wildly. The green world becomes a tomb of ash and sterile stone. The plant eaters suffer next. The great sauropods, whose massive bodies require enormous amounts of vegetation to sustain them, find nothing to eat. These magnificent creatures, some as long as 3 whales arranged end to end, grow weaker with each passing day. Their bodies, so perfectly adapted to a world of abundance, become liabilities in a world of scarcity. The Triceratops and Ankylosaurus browse for food in the darkness, finding only dead and dying plants. Young animals starve first, their smaller bodies unable to store reserves of energy. Then the adults begin to fail, one by one. The great predators do not fare better. The Tyrannosaurus rex, the apex hunter that has ruled for millions of years, finds no prey. The smaller dinosaurs that it hunted have vanished. Without food, even a creature as fierce and powerful as this cannot survive. These hunters that once inspired terror now wander aimlessly through ash-covered wastelands, their roars echoing across empty land, where once their calls meant death to those who heard them. The temperature continues to plummet. Ice begins to form, even in places where it had never formed before. The oceans grow cold and murky, their waters poisoned by chemicals released from the impact and by the decomposing bodies of countless creatures sinking to the depths. Many sea creatures that thrived in warm tropical waters find themselves in an alien environment. The pterosaurs, those magnificent flying reptiles that have soared through the skies for over 100 million years, struggle against the cold. Their metabolism, so finely tuned for warmth, fails them. Their wings become too heavy to lift. They fall from the poisoned sky. Weeks turn into months. The dust begins to settle, but it is replaced by a different horror. The ash that falls like gray snow continues to accumulate, burying plants and small animals alike. The darkness lessens only slightly. The cold does not release its grip. Rain, when it comes, falls as acidic poison from the polluted clouds above. The atmosphere itself has become toxic, filled with sulfur compounds and particles that burn lungs and corrode exposed skin. The Great Dying continues relentlessly. 75% of all life on Earth will vanish in this catastrophe. The age that has lasted 165 million years, the age of reptiles that has defined the world since the time of the first dinosaurs, is ending not with the slow passage of geological time, but in a blink of the eye. Small creatures huddle in burrows beneath the frozen ground. Some mammals, tiny and insignificant compared to the giants dying above, survive by consuming carrion and by living on the meager stores they accumulated before the darkness came. In caves, in deep ocean trenches, in the hidden places of the world, certain species endure. In this cold and lightless world, life faces another crucible, another test of its will to survive. With the asteroid's impact, a chapter of Earth's history that lasted 165 million years comes to a final, devastating conclusion. The moment of collision arrives not with sound, for sound cannot travel through the vacuum of space, but with an incomprehensible release of energy. 66 million years before this present moment, a rock the size of a mountain screams through the atmosphere above what will one day be called the Yucatan Peninsula. The sky tears open. Fire rains down across continents. The impact itself creates a crater 150 kilometers wide, and the explosion is so violent that it vaporizes rock, sending it skyward in a pillar of superheated material that rises beyond the clouds. The shockwave spreads outward like an invisible hand, pushing everything before it. Forests that have stood for millennia are flattened in an instant. The ground trembles across the entire planet. Tsunamis born from the impact surge across oceans, drowning coastlines under walls of water hundreds of meters high. And then comes the darkness. Dust and ash rise into the stratosphere, so much particulate matter that the sun itself becomes a distant memory. The sky transforms into a twilight realm where day and night lose all meaning. Temperatures plummet. The photosynthesis that has sustained life on Earth ceases. Plants wither. Herbivores starve first, their massive bodies requiring enormous quantities of vegetation that no longer exists. The great sauropods that have wandered Earth's continents for over 100 million years, creatures that seemed eternal, begin to die. They collapse where they stand, too vast to sustain themselves when the world's food chains collapse into silence. The predators follow soon after. The mighty tyrannosaurs, apex hunters that have ruled their domains with terrible beauty, find their prey disappearing. They hunt frantically, growing weaker with each passing day. The skies that once belonged to magnificent pterosaurs fall silent as those winged giants starve among the clouds. Eagles and vultures, have not yet evolved to claim these domains. The world is ruled by death. In the oceans, the story repeats itself with equal tragedy. The plankton that form the base of marine food webs die in the darkness. Fish populations collapse. The great marine reptiles, the mosasaurs and long-necked plesiosaurs, find themselves in an alien ocean where the fundamental structures of life have been torn away. They swim in search of prey that will never come. But life, in its most patient and determined forms, endures. In burrows and beneath fallen logs, in small caves and underground chambers, creatures that have learned to survive on the margins of the dinosaurs' world persist. Mammals, no larger than mice huddled together in the cold and darkness. These small, furry creatures with their fort-chambered hearts and efficient metabolisms require less food than their large cousins. Many survive by eating insects, seeds, and the corpses of fallen giants. Some eat each other. Survival in this new world means abandonment of all mercy. The smaller reptiles also persist. Lizards, snakes, and crocodiles, creatures with lower metabolic demands, find shelter in crevices and marshes. Turtles retreat into their shells. Amphibians burrow into mud. Birds, those living descendants of theropod dinosaurs, survive in small numbers, their feathers providing insulation in the bitter cold. Weeks become months. Months stretch into years. Slowly, impossibly, the ash begins to settle. The sky, though still dimmed, begins to brighten. The first green shoots emerge from the soil. They grow in a world forever changed. A world where the architects of the past have been erased. 75% of all species on Earth have vanished. Gone are the three-horned triceratops, the armored ankylosaurs, the swift velociraptors. Gone are the magnificent giants, whose footprints shape the landscape. The small survivors inherit a world emptied of its dominant voices. They move cautiously through the devastation, exploring territories that have suddenly become available. Evolution will work upon them now, gradually transforming them through millions of years to come. Their descendants will grow larger, diversify, fill the empty ecological niches left behind. The age of dinosaurs is over, but from their extinction, a new age will be born. In the aftermath of catastrophe, the small mammals that once hid in shadows now emerge to inherit a world waiting to be discovered and explored. Picture yourself standing in this transformed landscape 66 million years ago, where the dust has settled and the sun begins to shine through the clearing skies. The world is quiet in a way it has never been before, emptied of the great reptilian dominators that ruled for so long. And in this silence, something remarkable begins to stir. The mammals that survived the impact event were small, unassuming creatures, many no larger than a modern squirrel or shrew. They had endured in the shadows and underground burrows for over 100 million years, waiting, evolving slowly in the margins of a world that belonged to dinosaurs. Now, as the Paleocene epoch unfolds, these humble survivors find themselves in an entirely new world. The ecological niches, left vacant by extinct dinosaurs, stretch before them like endless territories waiting to be claimed. There are no large predators ruling the forests. There are no herbivorous titans consuming the plants. The stage is set for one of the most explosive diversifications life has ever witnessed. Feel the quiet transformation as you move through the early Paleocene forests. Here, the plants are beginning to recover from the climate shock of the impact. Flowering plants, which had only recently evolved before the extinction, now flourish and spread across the recovering landscape. The forests grow denser and richer with each passing generation. The mammals, sensing opportunity in this regenerating world, begin to change. They grow larger. They develop new shapes and forms. They adapt to different foods and different habitats. Within just a few million years of the extinction event, dozens of new mammalian orders have begun to emerge. Imagine walking alongside these early mammals as evolution sculpts them in real time. Some grow strong legs and become runners, built for pursuit across open plains. Others develop sharp claws and become climbers and diggers, specializing in newly available ecological roles. Some become fruit eaters, following the flowering plants into the canopy. Others become flesh eaters, hunting the herbivores that grow around them. The diversity is breathtaking in its speed and scope. Where there were once dozens of mammalian species worldwide, there are now hundreds, and then thousands. The Paleocene witnessed the origin of most of the major mammalian orders that we know today. The Eocene epoch arrives next, bringing warmer temperatures and even more lush conditions to much of the world. The mammals continue their remarkable expansion. Now you witness creatures that would seem familiar to modern eyes beginning to take shape. Early horses, no larger than dogs, begin their long evolutionary journey that will eventually lead to the magnificent steeds of later times. Primitive whales, still bearing the remnants of their land-dwelling ancestors, begin to explore the oceans. Creatures that will eventually become primates develop in the trees, setting the stage for the eventual evolution of humans. Early carnivores and ungulates diversify and specialize. The mammalian family tree branches and branches again, creating the foundation for all the mammal diversity we see today. Watch as these early mammals adapt to their expanding world with remarkable plasticity and creativity. They occupy deserts and forests, grasslands and wetlands. Some take to the trees, while others remain on the ground. Some become solitary hunters, while others develop social structures. The planet, still bearing the scars of the impact event, but now healing rapidly, becomes a laboratory of evolution where life experiments with countless new forms. The ecological balance shifts steadily away from the dominance of reptiles toward the ascendancy of mammals. These creatures, with their warm blood and active metabolism, their capacity for parental care and learning, prove themselves remarkably suited to occupying and diversifying into the available niches. The Paleocene and Eocene epochs become the crucible in which our modern mammalian world is forged. As you stand at the boundary between the Eocene and the epochs yet to come, you realize that you are witnessing the birth of the world we know. The mammals have claimed their inheritance from the dinosaurs, and they will not relinquish it. The age of mammals has begun, and evolution will now write a new story across the lands and oceans of Earth. The world emerges from the cold ashes of extinction into a warm embrace of sun and heat, a tropical paradise of green vegetation and warm seas. Imagine yourself floating gently above the planet, watching as the last remnants of the extinction event fade into memory. The Eocene epoch has arrived, and with it comes a remarkable transformation that will reshape life on Earth in profound and beautiful ways. The climate of this era is warm beyond what most of us have ever experienced. Even at the poles, where ice and snow once dominated, tropical and subtropical conditions now flourish. The temperature gradients between the equator and the poles are softer, gentler, creating a more uniform warmth that spreads across the entire globe. Ocean temperatures are balmy and inviting, rising to levels that would feel refreshingly warm to modern human skin. This warmth is the gift that allows life to explode into new forms with astonishing diversity and vigor. As you descend through the layers of this warm atmosphere, notice how the forests have transformed. The flowering plants that survived the catastrophe are now thriving with renewed purpose. Lush, dense jungles carpet the continents in vibrant shades of green, extending far beyond the equatorial regions where you might expect them. Flowering trees burst with color, their blooms attracting insects, birds, and small mammals in an intricate dance of pollination and reproduction. The air itself seems thick with life, with the soft rustling of leaves and the gentle calls of creatures moving through the canopy. The mammals that inherited this new world are experiencing their own golden age of evolution. The early primates, no larger than modern shrews and squirrels, are beginning their long journey in the trees. These small creatures, with their grasping hands and forward-facing eyes, are the ancestors of everything that will eventually lead to humans, though they cannot know this yet. They move cautiously through the branches, hunting insects and fruits, establishing themselves in the ecological niches that the flowering plants have created. Other mammals are also flourishing in remarkable ways. Early horses, no bigger than modern dogs, are beginning to experiment with grazing and running. Ancestral whales are taking their first tentative steps into the oceans, their bodies slowly adapting to an aquatic existence. Early carnivores with forms unlike anything alive today are prowling through the forests and across the grasslands. Each species is slowly, gradually becoming something new, shaped by the pressures and opportunities of this warm, abundant world. The birds, having survived the Great Extinction, are diversifying into an incredible array of forms. Some are becoming larger, developing specialized beaks and talons for hunting. Others are evolving intricate plumage and complex songs to attract mates. The tropical conditions provide an endless source of insects, seeds, and fruits to sustain this avian diversity. The morning chorus in these Eocene forests would be a symphony of sounds, unlike anything you might hear in the modern world. The oceans are equally vibrant with life. Warm currents circulate freely around the planet, carrying nutrients and heat to distant shores. Early marine mammals are beginning to diversify, along with countless fish species and invertebrates. Coral reefs, those delicate structures built by tiny polyps, are establishing themselves in the warm tropical seas, creating islands of incredible biodiversity and color. The oceans themselves seem to shimmer with vitality and possibility. What makes this epoch so remarkable is not just the warmth or the diversity of life, but the sense of renewal and purpose that permeates every ecosystem. This is a world recovering from trauma, rebuilding with enthusiasm and vigor. Species are exploring new niches, developing new adaptations, pushing the boundaries of what life can become. Evolution is working at a pace that feels almost joyful in its productivity. Settle into this moment of deep time and imagine the peace of such abundance. The anxiety of extinction has passed, replaced by the simple joy of survival and growth. Every creature, from the smallest insect to the largest whale ancestor, is participating in an ancient dance of adaptation and change. The world is warm, the plants are thriving, the animals are multiplying, and life is celebrating its miraculous persistence. In this warm and bountiful world, life celebrates its survival by creating new forms and new possibilities with remarkable enthusiasm. As millions of years unfold, the mammals that inherited the world become ever more diverse, evolving into the creatures that populate our modern world. Picture yourself drifting through time itself, witnessing transformations so gradual they seem invisible from moment to moment, yet so profound they reshape entire families of living things across millions of years. In the warm forests and savannas of this Cenozoic era, you observe small primates moving through the canopy. Their forward-facing eyes give them depth perception perfect for navigating branches. Their grasping hands manipulate their environment with increasing sophistication. Generation after generation, small changes accumulate. Some populations develop larger brains. Others find their way down from the trees onto the grasslands, where bipedal locomotion offers advantages for seeing predators and carrying food. This is the subtle choreography of natural selection, playing out across vast stretches of time that dwarf human history completely. You witness the spectacular return to the oceans. Watch as some land mammals venture into coastal waters and gradually become more aquatic. Their front limbs transform into flippers, their bodies streamline for movement through water. Whales and dolphins emerge as among the ocean's most intelligent and complex creatures, descendants of terrestrial ancestors, yet adapted perfectly to an aquatic existence. It is remarkable how life recycles its designs, adapting ancient mammalian templates to entirely new environments. As your timeless perspective continues, you observe the evolution of modern predator-prey relationships. Cats, with their retractable claws and explosive speed, develop to hunt across different terrain. Dogs evolve pack hunting strategies and incredible endurance. Herbivores develop keen senses to detect danger, faster legs for escape, and sometimes horns or antlers for defense. The arms race between predator and prey drives countless small improvements in both sides, each species pushing the other toward greater sophistication. The landscape transforms around you with remarkable dynamism. Ice ages come and go. Climate patterns shift and stabilize. Grasslands expand where forests once dominated. Deserts emerge and retreat. Life responds to each change with remarkable flexibility. Species migrate across continents. Some populations become isolated and diverge into new species. Others adapt in place to their changing world. Through it all, biodiversity increases, with millions of species occupying nearly every available ecological niche. You see early hominins walking upright across African savannas, their tool use becoming increasingly refined. The ability to make and use tools creates a feedback loop with brain development. Larger brains enable better tools. Better tools support larger populations. Larger populations create more innovation. This is the pathway that will eventually lead to humans, though you are watching it happen at an immense temporal distance, as an observer outside of time itself. Consider the flowering plants that now dominate terrestrial ecosystems. They co-evolve with insects that pollinate them, creating intricate relationships of mutual benefit. The colors and scents that seem so vivid to us today developed over millions of years of refinement. Butterflies and bees, beetles and moths all evolved alongside flowers, each relationship deepening and becoming more specific over time. It is a profound collaboration, written in the language of genetics. Throughout all these transformations, you sense the underlying process that drives everything. Mutation creates variation. Selection favors advantages. Time allows small changes to accumulate into major transformations. There is no consciousness directing these changes, no intelligence planning outcomes, yet the results appear beautifully designed, intricately complex, perfectly suited to their purposes. This is the power of evolution acting across millions of years, an impersonal force that nonetheless creates the most intimate relationships between organism and environment. As you continue your journey through the Cenozoic, the world becomes increasingly familiar. The mammals you see resemble those we know today. The plants look modern. The insects and birds feel contemporary. We are approaching the present moment in this vast history. The groundwork for all modern life has been laid through countless generations and billions of small changes. Evolution is writing the final chapters of a story millions of years old, creating the biodiversity we see today. In the vast tapestry of life that has evolved over billions of years, evolution takes one final bold step, creating consciousness itself. Picture yourself standing on the golden savannas of Africa, perhaps 5 million years ago. The landscape stretches endlessly beneath a vast sky, dotted with acacia trees and alive with the sounds of countless creatures. Here, among the grasslands and woodlands, something extraordinary is beginning to unfold. Primates that once swung freely through the canopy of forests have begun to adapt to life on the ground. Their bodies are changing, their brains are expanding, and something within them is awakening. Millions of years pass as you observe this remarkable transformation. Generation after generation, these creatures develop larger brains, more dexterous hands, and increasingly sophisticated ways of communicating with one another. They begin to craft tools, simple at first, then progressively more refined. They learn to harness fire, using its warmth and light to push back against the darkness, to cook their food, to gather around its glow and communicate through the long African nights. Watch as time accelerates in your mind, as thousands of years flow together like water. Different species of early humans emerge and vanish into the mists of prehistory. Homo habilis, Homo erectus, Homo neanderthalensis. Each one a variation on a theme, each one a step along an unimaginable journey. And then, perhaps 300,000 years ago, something new appears on the stage of Earth's long drama. Homo sapiens emerges, fully modern humans, bearing brains as complex as any alive today. These early humans possess something unprecedented in the billions of years of life on Earth. They do not simply react to their environment. They imagine possibilities beyond what they see. They create art on cave walls, hands stenciled in red ochre as if calling out across the millennia, saying, "Here I am, I existed, I mattered." They carve figurines from ivory and bone. They develop language so intricate it can express not just the present moment, but dreams, memories, and abstract concepts. They wonder about the stars above them and the meaning of the world around them. As you continue forward through time, you witness these humans spreading across the globe. From Africa, they migrate to every continent, adapting to deserts and ice ages, rainforests and mountains. They develop art and music and ritual. They create myths and stories to explain the world, to make sense of their place within it. They form communities, bound by shared meaning and purpose. The pace of change accelerates dramatically. What was once wilderness becomes cultivated farmland. Settlements become villages. Villages become cities. Knowledge accumulates, passed from generation to generation through spoken word, and eventually through writing. Mathematics and science emerge. Humans begin to ask the deepest questions. Where did we come from? What are the laws that govern nature? What is consciousness itself? In just the last few hundred years, humans have developed the ability to peer back through time using fossils and genetics. They have decoded the very instructions of life written in DNA. They have become aware of evolution itself, understanding the mechanism by which all life on Earth, including themselves, came to be. They have looked through telescopes at the vast universe and contemplated their infinitesimal place within it. They have walked on the moon. This remarkable creature, this human being, this consciousness arising from stardust and shaped by billions of years of evolution, becomes capable of understanding its own origin story. In the span of mere decades, humans have learned more about the history of life on Earth than in all of previous history combined. They have mapped the entire human genome. They understand, at least partially, how their own brains work. Yet even as humans achieve these extraordinary intellectual heights, they remain connected to all life that came before. Your body carries genetic instructions written billions of years ago. Your hands are shaped by the same forces that shaped fins and hooves and wings. Your emotions and instincts echo the needs and drives of ancestors living millions of years in the past. With humans, life becomes aware of itself, able to contemplate the very journey that brought it into existence. And so our journey through time concludes, bringing us to the present moment, to the world as it is now, to you listening to this story. Picture yourself standing in a quiet place, perhaps in nature, perhaps in your home. Feel the ground beneath your feet, solid and ancient. That ground has been here for billions of years, shaped by forces both violent and gentle, and it connects you directly to every chapter of this story we have traveled together. You are not separate from this history. You are woven into it, a continuation of the same grand narrative that began when our planet was nothing but swirling dust and cosmic debris. As you breathe in this moment, consider the oxygen filling your lungs. That oxygen was produced by plants and countless microscopic organisms, just as it has been for hundreds of millions of years. With every breath, you are participating in cycles that began long before your species existed. Cycles that have sustained life through ice ages and meteor strikes, through the rise and fall of countless species. Your body, in this very instant, is a walking collection of elements formed in the hearts of dying stars, arranged and rearranged by evolution into the particular pattern that makes you uniquely yourself. Think about the other living things sharing this planet with you right now. The bird singing outside your window carries within its DNA the echoes of dinosaurs, its ancestors having survived that great extinction event 66 million years ago. The insects in the soil beneath trees, the fish in distant oceans, the forests growing silently across continents. All of them are your cousins, separated by time and adaptation, but connected through an unbroken chain of reproduction, stretching back to that first moment when life emerged from the chemical soup of early Earth. When you look into the eyes of another animal, you are looking at a relative who has traveled a different path through time, but a relative nonetheless. And when you look at another human being, you are seeing someone who shares with you the same recent ancestry, whose ancestors walked the same savannas, survived the same ice ages, learned to make fire and build shelter and dream of worlds beyond their own. Every person you encounter carries within them the same billions of years of evolution, the same inherited wisdom written in their genes, the same capacity for creativity and compassion and wonder that evolved slowly across countless generations. The natural world around you is not a backdrop to your existence, but a living partner in it. The forests breathe with you. The oceans pulse with the same rhythms that pulse through your blood. The soil nurtures the plants that feed you with the same patience it has shown for millennia. When you damage nature, you are damaging yourself, for you are not separate from it. When you honor and protect the wild world, you are honoring the billions of years of struggle and adaptation that brought you into being, that made you possible. This present moment is neither an ending nor a beginning. It is a continuation, a single note in a symphony that has been playing for 4.5 billion years. You are the universe becoming aware of itself, evolution's way of contemplating its own journey. In you, the ancient rocks have learned to think, the oceans have learned to wonder, the stars have learned to feel. You carry within you the memory of the first single-celled organisms, the determination of the first creatures to leave the water, the resilience of our ancestors who survived countless perils. The future remains unwritten. What happens next depends on choices made by you and billions of others, by the collective decisions of humanity as it matures into understanding its place in the larger system of life. You have inherited not just genes but responsibility, not just survival instincts, but the power to shape what comes next. In this moment, take a breath and feel the weight of that connection. Feel how you are held within the continuity of life, supported by billions of years of evolution. Feel the peace that comes from understanding that you are not alone, not separate, but part of something vast and beautiful and continuing. We are made of stardust, born from the evolution of billions of years, connected to all life on Earth. And in that connection lies both humility and wonder.